Hello, my dear students. Welcome to PW English Medium Class 9th and 10th YouTube channel. My name is Ashok SK. I'm your physics teacher. Students, in a Spartan's batch, we have already covered two chapters, right? So today we are going to start with a third chapter, that is a light reflection and refraction. And it is very important for your board examination. Okay. So without wasting our time, let's get into the topic. So chapter name, light reflection and refraction, and subject of physics. Okay, under science, the subject of physics. And this chapter going to be one short lecture. That means we are going to cover all the topics in one go. Okay, and batch name, Spartan's batch, and this is class 10th students. Okay, this is purely dedicated for class 10th students. Okay, especially CBSE students, right? So in this particular session, we are going to cover with entire chapter with a first topic, that is light reflection. In the beginning, we are going to understand what is light and what is light reflection. Okay, so after that, laws of reflection. We can expect one question based on this topic, that is the laws of reflection. Okay, so after that, image formation by spherical mirrors. So this is the first part of light, that is the reflection. Okay, light reflection. After image formation by spherical mirrors, we are going to learn about light refraction. Okay, you have to concentrate on these two terms. Okay, reflection and here refraction. Okay, so after reflection, we are going to learn what is the light refraction and what is laws of refraction. And in the same way, like a mirrors, image formation by spherical lenses. Okay, so like mirrors, here also we are going to discuss about image formation by spherical lenses. And please note this third point. Okay, this third point, that is the image formation by spherical mirrors, and fifth point, image formation by spherical lenses, are very important for your board examination. Okay, so let's start with first topic, that is the light. So what do you mean by light? Previous classes like 8th grade or else 9th grade, you have learned about heat as well as the sound, right? So heat, if I consider, what is heat? Heat is a form of energy which gives a sensation of warmness, right? If I consider a sound, it is also a form of energy which gives a sensation of a hearing. If I consider a light, okay, this topic, if I consider a light, without light, are you able to see this beautiful world around? It is not possible. So light is necessary to witness this beautiful world around us, right? So can I say light is also a form of energy which gives us a sensation of a vision to our eyes? Yes, definitely you can consider light is the form of energy which gives us sensation of a vision. Okay, so then coming to the definition, we can note down. Okay, so exam point of view, they do not ask definition of a light, but you have to know what is light. Okay, so in a simple word, you can say it is the form of energy which gives a sensation of a vision. That's all. Okay, so it is the form of energy which provides sensation of a vision to our eyes. Okay, fine. Then what is the speed of light? Okay, so it is depends on a medium. Okay, so it is depends on a medium. If I consider mediums, okay, so state of matter, if I consider in the same basis, there are three mediums. Okay, so solids, liquids, and the gases. Okay, so but here with respect to light, we have to consider optical medium, that is nothing but transparent medium. So in transparent medium also, there are three mediums. One, it is the first one if I consider a solid medium. Transparent medium if I consider for a solid medium, it is the glass. And if I consider a liquid medium, it will be a water, example, okay. And if I consider gaseous state, transparent medium will be air, okay. So based on the medium, speed of light going to change, okay. So all these speed of light we are going to learn under second section of this light, that is the refraction, okay. So here generally if I write the speed of light in an air medium, okay, speed of light, okay, speed of light in vacuum or air, if I consider, it is represented by C, okay. C is the speed of light in an air or vacuum, and the speed is 3 into 10 power 8 meter per second, okay. So this is the speed of light in an air or vacuum. This one we can call it as a 3 lakhs kilometer per second, okay, 3 lakhs kilometer per second, fine. And the next one of the very important property of a light, okay. So if we talk about the properties of a light, okay, there is a reflection, okay, refraction and dispersion, diffraction and interference. For class 10th, we need only two properties of light. The first one, that is the light reflection. Second one, that is the light refraction. Okay, so let's discuss in detail about light reflection. Okay, so here reflection. So if I talk about a reflection, what does that reflection means? Reflection is nothing but a coming back or else bounce back. So as we are discussing about a light, so here we are talking about a light ray. The bouncing back of light ray into the same medium after striking the surface which is separating two media is called light reflection. It is the property of a light, okay? It is the one of the properties of a light. First property, you can say first property of a light, that is the light reflection. Bouncing back of light into the same medium after striking a surface, okay? If we consider a laser light, okay? If we consider a laser light, take one a mirror, okay? Take one mirror and just switch on that laser light, okay? So make sure that a laser light strikes the surface of a mirror, okay? So what you can observe, when the laser light strikes the surface, that laser light will bounce back. That phenomena, we call it as light reflection, okay? Right. So our next topic, that is reflection of light, okay? Reflection of light. The bouncing back of light ray into same medium after striking the surface which is separating two media, okay? So if I consider this is a medium 1, okay? So if I consider this is the medium 1, okay? This is medium 1 and this is a medium 2. This is a medium 2. Fine. And this is a surface. Okay. So this is a surface. This is surface. Or else you can call it as a boundary. Surface or a boundary which separating two medium. Medium 1 and medium 2. What are these, the medium 1 and medium 2? Optical mediums, okay? So let me consider this is the first medium, air medium, and this is the second medium, glass medium, okay? And here, example, I'll consider a mirror, okay? So let me consider this is a mirror. And this cross lines indicates a coated surface, okay? This cross line indicates coated surface. Coated surface. Now, if I consider, okay, if I consider ray of light, okay, ray of light, which is incident on a surface which is separating two medium, okay? So this point we are calling it as a point of incidence, okay? Point of incidence. And here you need to concentrate on my words, okay? You need to concentrate on my words. What is this? Perpendicular. Okay, so this is a perpendicular drawn. Perpendicular means 90 degree. Perpendicular drawn to the surface at a point of incidence. This point is the point of incidence. Okay. After that, according to the property of a light, it will reflect back into the same medium. It will reflect back into the same medium, and this ray we are calling it as a reflected ray. So I indicates incident ray and this one indicates a reflected ray, and this dotted line indicates a normal. So in mathematics, normal means a perpendicular, perpendicular means 90 degree with respect to angle. Okay. So here first medium, the light ray has struck this mirror and bounce back into the same medium. Okay. And here you need to concentrate on 5 to 6 terms. The first term, okay, that is incident ray. Incident ray means the ray strikes the mirror or else a surface. Second one, a normal. Normal means the perpendicular drawn to the surface which is separating two media. Okay. And this is a reflected ray. Reflected ray means it is a coming back, a ray which is, bounce back from the mirror is called a reflected ray. Okay. So all these are with respect to rays. And one more, not one, actually two angles. One is angle of incidence, second one angle of reflection. So if I consider the first part, okay, this is angle of incidence, theta I. Theta means angle, I means incident angle. I indicates incident angle, or else you can call it as an angle of incidence. Getting my point? And after that, the second one you can consider angle of reflection, theta R, angle of reflection. Getting my point? So 5 terms are very, very important: incident ray, normal, reflected ray, angle of incidence, and angle of reflection. Okay. And this is the mirror or else boundary or else surface with separating two media. Getting my point? So this is the definition of reflection of light. Next one, important terms related to light reflection. Okay, important terms related to light reflection. Okay, it is not just a light, it is a light reflection. Light reflection. Okay, light reflection. Fine. The first term, that is the incident ray. Incident ray means this one. Okay, pink color one. The ray which strikes the surface. Second one, the second one, normal. What is that normal? The perpendicular drawn to the surface which is separating two media. A perpendicular drawn to the surface at a point of incidence. Okay. And the third important term, that is the reflected ray. The ray which bounces back into the same medium after striking the surface. This one. Okay. White color one is a reflected ray. Okay. Next one. Next one, angle of incidence. So this one can be written as, okay, this one can be written as theta I. Okay, the angle between incident ray and normal. Okay, so here you can observe this angle lie between two lines. Okay, lie between two lines. One is a normal, another one is incident ray. So how to define this angle of incidence? The angle between normal and incident ray is called angle of incidence, and theta R, which indicates angle of reflection. But how to define it? The angle, it is between a normal and reflected ray. Okay, how to define it easily? Okay, you see the angle between normal and reflected ray is called angle of reflection. Simple. Okay, right. And the next one, angle of reflection, that is the theta R. The angle between reflected ray and normal is called angle of reflection. Simple. So these 5 terms are very important with respect to, light reflection. Next one. So in this particular chapter, we are going to use 4 important terms. Okay, 4 important terms. That is object image, and virtual image and virtual object, and the next one real image and virtual image. Okay, clear? So first we are going to talk about object and image, types of image, real and virtual. Okay, step by step. So first one, what is the meaning of object and image? So when you stand in front of a mirror, okay, reflecting surface, not only mirror, any reflecting surface. So if you stand, just example I'm considering, if you stand in front of a mirror at your home, okay, anywhere, but example I'm considering at home while getting ready for the school, okay. So you'll be standing like this, okay, you'll be getting ready. So your reflection will be visible in the mirror. What is that reflection? Actually, that is the image of your body. That is actual representation of a body or else object is called image. Okay. But you see, one important observation, your right hand side will be visible in the mirror as a left hand side. Left hand side will be visible as a right hand side. Okay, so this one we call it as a lateral inversion. But this time, this academic year, they have removed this lateral inversion. Okay, so no need to worry about it. Okay, so just we need to understand what is image and what is object. If I stand in front of a mirror, okay, that is a plane mirror or else whatever reflecting surface it is. Okay, so if I stand in front of a mirror, so myself acts as an object and in the mirror it acts as a image. But how to represent in an examination? That is our concern. We know that myself, if I stand in front of a mirror, myself as an object acts as an object, but inside the or behind the mirror acts as a image. Okay, image of an object. So simple thing is, you know, in examination it is not there in your textbook. Okay, it is not there in your textbook. Try to understand. So object means rays falling on the mirror. Okay, so simple, rays falling on the mirror is called object, or the point of intersection of incident rays. Incident rays means already we know that the rays which strikes the mirror. Okay, which one is it? That one you can consider. Okay, here I'll consider both. Okay, one is rays falling in the mirror or else the point of intersection of incident rays. Okay, so here I'll consider an example. Here I'll consider one example. Let me consider this is the body. Okay, this is the object or body. Object or body. So here try to understand. So from this body, the rays will be striking the mirror. Rays will be striking the mirror. Rays will be striking the mirror. Any number of rays you can consider. Any number of rays you can consider. Okay, so here I'll be considering these many rays. So this one indicates, you know, object. This one indicates object. But what kind of object it is? Again, object, there are two types of object. One is real object, another one is a virtual object. But in reality, we see a real object itself. Okay, real object. So for a class 10th students, virtual object it is not required. We are going to consider only real object. Sir, what is the difference between real object and virtual object? Okay, so here I have considered, okay, here I have considered this as a mirror. This as a mirror. Okay, so this one is a mirror. So according to the concept, object means, okay, the point of intersection of all the incident rays or else the rays falling on the mirror. So this is the mirror. That means all the rays falling on the mirror. So these rays coming from the object. Okay, so here actually the rays are falling on the mirror from the object. So here you can consider a real object. Then what about a virtual object? Let's try to understand. Okay, so according to the condition, okay, according to the definition, okay, according to the definition, let's consider the same way. This is the mirror. Okay, this is the mirror. This is the mirror. Fine, this is the mirror. And incident rays I'll consider. Okay, The first one, okay, I'll change the color. First ray, second ray, any number of rays you can consider, okay? Any number of rays you can consider. Third ray, and fourth, fifth, sixth, okay, and seventh, eighth, whatever number, okay? So according to the concept, the rays falling on the mirror is called object, okay? Is called object. All these are incident rays, okay? All these are called incident rays. Fine, IR indicates incident rays. Now, where is the object then? Where is the object then? Where is the object then in this particular case? Are you able to see the object here? No. But here there is actually the incident rays are coming from a different direction. Okay. But intersection of incident rays we have to consider. Okay. Intersection of incident rays. Intersection means meeting point. Okay. All the rays meet at one point. That point we call it as the intersection of all the incident rays. Okay. So according to the concept, again, if I join or else if I draw extended lines of all the lines, okay, extended lines, you see, extended lines, okay, extended lines, fine, extend lines. Here you are able to observe, if I extend all the incident rays behind the mirror, okay, this is the coated surface. Behind the mirror, if I consider, all the rays are meeting. They're not actually meeting, but appears to meet at one point. Wherever I use appear, that indicates a virtual. All these incident rays are not actually meeting. What happens after striking the surface? These rays will reflect back. They do not, pass through the mirror according to the property of a reflection. But just we are imagining, okay, just we are, just visualizing, what if there is no mirror? This line would have traveled in a same direction in a straight path. Am I right? So by that concept, if we imagine, okay, so all these incident rays appears to meet at this particular point, and this object we are calling it as virtual object. Virtual object. Okay, so simple. Okay, try to understand after explanation of all these concepts, means the real object and virtual object, in a simple word. Okay, in a simple word, if all the incident rays are actually meeting, so in this particular case, all the incident rays are meeting at this point. Okay, so this one we call it as a real object. But in this particular case, all the incident rays are not meeting, but appears to meet. They're not actually meeting, but appears to meet. So therefore, we can call it as a, virtual object. Okay. So object means the intersection of all the incident rays, or else the rays striking the surface. We call it as an object, whether that is the reflection or refraction, whatever it is. Okay. Right. Then let's move on to the image type. Here, rays falling on the mirror. What if the rays are coming or bouncing back from the mirror? Then what do you call that? That is a image. Let's see how to understand this one. Okay. So first one, image, rays away from the mirror. Rays away from the mirror, or the point. Okay, the point of intersection of reflected rays. In the first case, object case, that is the incident rays, but here reflected rays. Okay, now let's try to understand. Okay, so this is, let's consider this is the mirror, and from the mirror, the rays from the mirror, rays are away. Away means the direction we have to show. Away from mirror. and all the reflected rays. So this away from the mirror indicates a reflected rays. Okay, so these are reflected rays, RR, reflected rays, and all these points meet at this point. Okay, all these reflected rays meet at this point. We call it as a intersection of reflected rays, and this one we call it as a real image. Real image. Okay. So incident ray, if I consider, that is the object. If I consider reflected rays, then it is the image, real image. Sir, what if these reflected rays do not meet? Right? That is also possible, right? Now, here you consider the first line, second line, and third line, and fourth line, and fifth line. Line means rays. Okay, you can consider any number of rays. Okay, any number of rays. Now here is the away from the mirror, means we have to show the direction away from the mirror. Now what do you think? All these rays are diverging from each other. Diverging from each other. Do you think all these reflected rays meet at any point? No, it is not possible. Really, it is not possible. But virtually means, just imagining, what if there is no mirror? Okay, what if there is no mirror? All the reflected rays would have meet at this point, right? Would have meet at this point. Right? Would have meet at this point. And this one, okay, so this point is the intersection, or else appears to meet. So here these are reflected rays. Reflected rays are not actually meeting, but appears to meet behind the mirror. Okay, appears to meet behind the mirror. So in this particular case, we can ask, sir, which side is the reflectant surface and which side is the coated surface? Okay, so if it is the reflecting back, means, so this is okay, this is coated surface. This is coated surface. Okay, and here also this is a coated surface. This is a coated surface. Okay, and this image is virtual image. Virtual image. Okay, virtual image. Clear? And here we need to differentiate between real and virtual image. Okay, what is the difference between real and virtual image? Try to understand. These points are very, very important. Point number one. Okay, point number one. So for a real image, okay, for a real image, all the reflected rays are meeting, are actually meet. Okay, example here you can consider. All the reflected rays are actually meet. But in case of a virtual image, okay, virtual image, if I consider a virtual image, all the reflected rays or appear, not actually, okay, appears to meet. Here you see all reflected rays are diverging, but if I consider, just imagining, what if there is no mirror, all the reflected rays appears to meet. Okay, now second point, this is the first point. Okay, this is the first point, and the second point, real image, it is inverted. Inverted means another name for it, upside down. Okay, upside down. Okay, upside down. Okay, now in case of a virtual image, I'll explain what is that. Okay, what is this inverted upside down? Okay, I'll explain, don't worry. This one, virtual image, it is erected. It is erected, or else, upright. This one, here, all right, upright. Okay, And what is this real image? Inverted, and virtual image upright. Okay, so let me consider an example. Okay, so if I consider an object, okay, if I consider an object for a real object, okay, a real object, a real object, this is the real object. If the image appears, okay, if the image appears in the same way, if the image appears in the same way, if the image appears the same way, then this one we call it as a upright or erected, same as image, sorry, same as object. This is a image, okay, this is image, and this is object, and this is the image. Getting my point? And what if image looks like upside down? Okay, if image looks like upside down, okay, so this is object and this is the image. You see, same size, but here it is a head and here it is a head upside down. So this one we call it as a inverted, okay, inverted or upside down, upside down. So these are the very important points related to real image and virtual image. Okay, so till now we have completed what is light and what is reflection of light and object and image. Okay, so by visualization, let's try to understand what is reflection. Okay, so I'll reduce a brightness so that you can observe. Okay, so this is the object, so I'll increase the size of the object. Here we have a mirror, so diameter also I'll increase, means the length of the mirror. Okay, so hopefully it is visible, right? So here there is a object in front of a mirror. So let's see what will happen. Let's see what will happen. So I'll consider rays. Okay, clearly you have to give attention. So first what will happen is two rays will start traveling from object to mirror. So those are incident rays. After striking, they'll come back. Let's try to understand. Okay, you see. So first they'll strike the surface, that is the mirror, and come back. Okay, so this phenomena we call it as a light reflection. Not only this object, you can consider any object. Okay, so instead of arrow, I'll consider a star. Okay, but size is a little big. Okay, so let's see. So incident rays, and this is a reflected ray. And one more object. Pencil, if we keep in front of a mirror, let's see. Incident rays. So light will travel towards the mirror. After striking, it will bounce back. So that phenomena we call it as a light reflection. Okay, clear? Right. Come back to the theoretical part. Simulation. Hopefully you understood what is real object and image. So this is a virtual image. Okay, so this is a virtual image, and this is real image. Okay, right. So in the simulation, what type of image it is? Let's see. Right, so this is the mirror and this is the object, this is the image of an object. So what type of a mirror image it is, whether it is a real or virtual? It is the virtual, because you see, same as it is. Okay, so this type of image we call it as the virtual image, erected, upright. Getting my point? So if I consider this image, okay, this is the object and this is the image. So this is object, image is a downward, means upside down, inverted. So this kind of image we call it as a real image. And one more important point related to this virtual as well as a real image. Okay, if there is a space I can write, or else here I'll write. Okay, so fourth point, real image can be obtained on screen, where virtual image, okay, so virtual image cannot be obtained on screen. But where does this image will be seen? Behind the mirror. Okay, behind the mirror we can see the image. Okay, so that kind of image we are calling it as a virtual image. Okay, right. So very important topic. The next one, that is the laws of reflection. Okay, laws of reflection. So if I consider this is a mirror. Okay, this is the mirror, reflecting surface. Okay, not only mirror, reflecting surface you can consider. Okay, reflecting surface. And so I'll consider the first part, that is incident ray. Okay, this one is the incident ray. So incident ray is represented by arrow mark. That means it is moving towards the mirror. And this one we call it as an incident ray. Got it? So the point where incident ray strikes the surface, that we call it as a point of incidence. And from point of incidence, if I drop perpendicular, okay, if I drop perpendicular, that we call it as a normal. Okay. After striking the surface, reflecting surface, here this one is reflected ray. This one is reflected ray. RR, reflected ray. And direction away from the mirror. And this is the normal. Okay. The angle between incident ray and normal, we are calling it as a angle of incidence. Correct? And angle between normal and reflected rays, we are calling it as a angle of reflection. Clear? So based on this observation, we have two laws. What are those? The first one you can observe at a point of incidence. Okay, at a point of incidence, the incident ray, normal and reflected rays lies in the same plane. What is that a plane? So if you see, let's try to understand with the example. Okay, you can see 5 fingers, right? So in that way, if you see, all the 5 fingers will be visible. Okay, so if I hold like this, okay, you are able to see only one finger. It looks like only one finger, right? That means all the fingers are in a same plane. If you see only one finger. What if I consider like this? All the fingers you are able to see. That means all the fingers are not in a same plane. So that is the meaning. Okay. So like a fan blades. Okay. So all the 3 fan blades are in a same plane. Getting your point? Okay. Now, according to the laws of reflection, here we have the first law, that is the angle of incidence is equals to angle of, okay, this one is a reflection. Okay, small error. Okay, right, this is a reflection, angle of reflection at a point of incidence. Okay, so here I can write theta I, that is equals to theta R. In some textbook, they have given angle of incidence that is equals to angle of reflection. This is the second method to express angle of incidence that is equals to angle of reflection. Okay, and the second law, already I have explained, the incident ray, normal and reflected ray at a point of incidence all lie in the same plane at this point. All the rays lie in a same plane. So let's try to understand how angle of incidence is equals to angle of reflection at a point of incidence. Okay, right. So we can understand by the simulation. Okay, I hope you are able to see the simulations or screen. Okay, so I'll reduce the brightness so that it will be visible, clearly visible. Okay, and you need to concentrate on this line. Okay, not this one. Okay, this is actually refracted ray. Ignore this bottom line. Okay, bottom red line. Concentrate on this. Okay, so first it is the surface which is separating two media. One is air medium and second one another medium. Okay, maybe you can consider glass, water, whatever it is. So this is the first medium and second medium. So from the first medium, the light is striking the surface which is separating two medium at this point. Okay, so dotted line indicates it is a normal. So what I will do is, I'll change it to the red color. See, I'll indicate angles also. Here you can see this is the incident ray. Okay, this is the incident ray and this is the reflected ray and this is the normal. Are you able to see the angle between normal and incident ray? That is the 46.7 degree. Normal and reflected ray, that is also 46.7 degree. What if I change the incident angle? See, you see at this point 30 incident angle, that is 30.6 degree, and reflected angle, that is also 30.6 degree. Whatever, for whatever angle you keep, angle of reflection, angle of incidence will remain same. Okay, so here 70.1, 70.1 degree. Angle of incidence and angle of reflection always equal. Getting my point? Okay, now for whatever color, okay, you can consider any color. Okay, angle of incidence, this is the angle of reflection, this is the angle of incidence, this is the angle of reflection, this is the angle of incidence, this is the angle of reflection. Okay, so this is the meaning of a first law, this one, angle of incidence, that is equals to angle of reflection, always equal. Getting my point? Okay, right. So I'll increase the brightness. Next topic are types of mirrors. Okay, so till now we have discussed about a reflection surface. Okay, that reflection surface can be a flat or else a plane or else spherical. Spherical means a curved surface. Okay, so if we consider a walls, okay, walls which is made up of a granite, okay, with the help of a granite, if the house is built, so that granite wall looks like a reflecting surface. It acts as a mirror. If we consider the surface of a granite, that can be flat. So based on that, mirrors are two types based on the surface. One is a flat surface, another one is curved surface. Based on the shape of a surface, here we have categorized mirrors into two types. The first one a plane mirror, the second one spherical mirrors. So in this particular year, okay, for 24-25, they have removed a plane mirror. It is not there. If you see the NCERT textbook, it is not there. Okay, and the second one, if the surface is a plane, simple, by the definition only, by the meaning, plane means the reflecting surface is a plane. Okay, reflecting surface, reflecting surface, reflecting surface. Based on reflecting surface, here we have two types, mainly two types. The first one, if the reflecting surface is a flat or plane, we can call it as a plane mirror. Example here you can see. Okay, example here you can see. This is the reflecting surface. This is the reflected surface. Okay, it is the plane. There is no curve at all. If I consider this one, okay, it is a curve. Black color you can see, right? I'll reduce the brightness so that you can observe. Here you can see a black line, right? That indicates a reflected surface, and behind it, opposite to it, that is a coated surface. And not only this curve, opposite of that also, okay, initially the reflecting surface bulged inward. Okay, this one we call it as generally concave mirror. And if a reflecting surface bulged outward, then it is called convex mirror. Okay, so based on a reflecting surface, mainly we have categorized mirrors into two types. The first one, a plane mirror, second one, spherical mirror. Again, based on the curve, that is a reflecting curve, maybe inward, maybe outward. That is nothing but bulged inward and bulged outward. So again, spherical mirrors categorized into two types. The first one, concave mirror. The second one, convex mirror. So here you see concave mirror means the reflecting surface is a bulged inward. It looks like a spoon only. Okay. And here dotted line indicates a coated surface. Okay. Coated surface, and this side, okay, this side, it is a reflecting surface. This is a reflecting surface. This is a reflecting surface. Getting my point? So if the reflecting surface bulged inward, then you can call it as a concave mirror. What if reflecting surface bulged outward? Bulged outward. This is a coated surface again. Okay, coated surface. And this side is a reflecting surface. Reflecting surface. Then you can call it as a convex mirror. Okay, so simple. If the reflecting surface bulged inward, you can call it as a concave mirror. If the reflecting surface bulged outward, you can call it as a convex mirror. Okay, so mainly the mirror is classified into or categorized into two, that is the plane mirror and spherical mirror, based on a curvature or else a reflecting surface in a spherical mirror. Again, there are two types. The first one, concave mirror, the second one, convex mirror. If the reflecting surface is bulged inward, then you can call it as a concave mirror. If the reflecting surface is a bulged outward, you can call it as a convex mirror. Okay, so in mirror case, you may get one question. Okay, okay, hot question. Okay, hot question means higher order thinking. Higher order thinking based question they can ask. Okay, so in case of a mirror, you can expect only reflection. You can expect only reflection, not refraction. Okay, so this is all about types of a mirror, and let's try to understand in detail about a concave mirror and convex mirror, and how these mirrors can form a image, and what are the characteristics of the image, whether image is real or virtual, whether image is a magnified or a diminished. So magnified means the size of the image. If it is a more than size of the object, then it is a magnified. If the size of image is less than size of the object, then it is a diminished. Getting my point? Easy to understand. I'll explain in detail. Okay, so let's try to understand in detail about concave mirror and convex mirror. So first, if I consider a spherical mirror, how it is made up of. If I consider one sphere, okay, if I consider one sphere and split into this way, and here you can consider, this is the first part and this is the second part. Okay, so I'll fill the gap so that you can understand easily. Okay, see this one. Okay, this is a reflecting part and this is also reflecting part. So if I consider the first one, okay, this is the first one, this is a reflecting part, and the second part, if I consider, this is the reflecting part. So same way, if I consider this side, okay, so this is this part, okay, the first part, this is the first part. That means this is a reflecting surface and behind it, it is a coated surface. Coated surface I'll show with a cross lines. Okay, this is the coated surface, and this is a reflecting surface. This side is a reflecting surface, and this one we call it as a concave. Okay, this one we call it as a concave mirror. In the same way, The second one if I consider, okay, second one if I consider, same, the second one, this is the reflecting surface. This is the reflecting surface. One second. Ulta. So here, one small, this is not reflecting surface, okay. This is actually reflecting surface. The reflecting surface is bulged outward, okay. This is the reflecting surface. This is the reflecting surface, okay. Here I said these colors indicates a reflected surface, right? Reflecting surface, no, only one reflecting surface, and this one is a coated surface, and this one is a coated surface. Coated surface, and this one you can call it as a convex mirror. Convex mirror. Okay, clear? There are some important terms related to these spherical mirrors. Maybe it is a concave mirror or else a convex mirror. Okay, maybe concave or convex. The first term you see pole of the mirror. Okay, so first term pole of the mirror. What is this pole of the mirror? See, please try to understand. Here you see the midpoint of the mirror, or else the midpoint of reflecting surface is called pole of the mirror. Maybe it is a concave or convex. The first point, this is a midpoint of reflecting surface represented by pole of the mirror. In the same way, for a convex, the midpoint of a reflecting surface is called pole of the mirror. Okay, pole of the mirror. The first point, it is clear. See, the center of reflecting surface of a spherical mirror. This is also spherical and that is also spherical mirror. Okay, the next one, center of a curvature. What is the center of a curvature? So if I consider, it is a part of the sphere, right? It is the part of the sphere. If I consider from here to here, and from here to here, okay, from here to here, and what is this? Center of the sphere, right? This is the center of the sphere. Center of the sphere. Okay, so this is the center of the sphere. So here, if I consider, if I try to make a sphere, this will be the center of the sphere, right? This will be the center of the sphere. So from the pole, if I consider, this is the center of the sphere. Okay, so this is the center of the sphere. Okay, this is the center of the sphere. At the same time, this is the second part. This is a reflecting surface. Okay, for this, it is the reflecting surface. This is the reflecting surface for the second one, reflecting surface. So in this particular case, what is the center of curvature? This side. Okay, center of curvature towards the right hand side. So here, center of curvature. Okay, center of curvature is nothing but the center of the sphere. Okay, which is the part of a sphere. Okay, why do we call it as a center of a curvature? Because it is the part of the sphere, not completely sphere. It is the part of the sphere. That is the reason we are calling it as a curvature. Okay, so by the definition, if you see center of a curvature, the reflecting surface of a spherical mirror forms a part of a sphere. This sphere has a center. This point is called center of a curvature of the spherical mirror. Okay, definition. You can expect one definition from these 4 to 5 terms are there. Okay, with respect to spherical mirrors. Okay, and radius. So radius is nothing but the length from pole to the center of curvature. Okay, pole to the center of curvature. So pole to the, this is the center of the, this is the center of curvature of the mirror or a spherical mirror, and a distance from pole to the center of curvature, we call it as a radius of curvature. In the same way here also, from pole to the center of curvature, we are calling it as a radius of curvature. Clear? Okay, now next one. So radius of curvature definition wise, so same like a center of curvature only. The radius of a sphere of which the reflecting surface of a spherical mirror forms a part is called a radius of a curvature of the mirror. Okay, so we are calling it as a curvature because it is not a completely sphere. It is the part of the sphere. That's all. Okay, and the next one, principal axis. So principal axis, okay, the principal axis. What is this principal axis? You see, a straight line, okay. Let's try to understand. It is the straight line. It is the straight line which is passing, okay, passing through pole and center of the mirror. So if I consider this the pole, a straight line which is a passing through center and the pole of the mirror, okay, pole of the mirror, and this one we call it as a principal axis, okay. So this one, principal axis, PA, principal axis. Here also same way, the center of a line, it is a straight line which is passes through pole to the center of curvature. Here you can define in another method also. The principal axis is nothing but it is a straight line joining pole and center of curvature. Okay. Anyway, which one is the? You can go ahead with that. Okay. A straight line passing through the pole and the center of curvature of a spherical mirror. This line is called the principal axis. Got it? Next one. Aperture. What is this aperture? Aperture is nothing but, okay, aperture is nothing but, you try to understand the diameter, okay, so from here to here, okay, diameter, the diameter of, you know, a reflecting surface is called aperture A, okay. The diameter of reflecting surface, maybe it is a concave or convex, the diameter of reflecting surface, okay, diameter of reflecting surface is called aperture. Simple. The diameter of reflecting surface of a spherical mirror is called aperture. Next one, principal focus. What is this principal focus? All the reflected rays are meeting, are intersecting at a point on the principal axis of the mirror. For example, let's consider, okay, so let's consider a concave mirror, okay. So reflected rays means it is coming from, okay, coming from a mirror, right? Coming from mirror, coming from mirror. So from end to end, okay. So we can consider any number of reflected rays, okay, any number of reflected rays. So all these are reflected rays only, okay. So this point, okay, this point we are calling it as a principal focus, represented by F, okay, represented by F. Principal focus is nothing but all the reflected rays, the point or the intersection of all the reflected rays is called a principal focus on the principal axis. Why do we call it as a principal focus? Because it is the point all the reflected rays are meeting, where on the principal axis. So that is the reason we are calling it as a principal focus. What if this intersection below or above the principal axis? You can call it as just, you know, focus. Okay. So if the point lying on the principal axis, then only you can call it as a principal focus. Okay. So in this particular cases, if we consider, so this is one reflected ray and second reflected ray and third reflected ray and fourth reflected ray and fifth reflected ray, any number you can consider, okay. So all these are reflected rays. All these are reflected rays, okay. So this is also point of reflected rays that we call it as a focus, okay. Here you can observe, okay. So this is also in front of a reflected rays, okay. This is also in front of a reflected rays. But the condition is here whatever I drew the lines, okay, all these reflected rays that do not meet actually, okay. It is a diverging mirror, okay. So this is a converging mirror. So this is a converging mirror, okay. This is converging mirror. Converging mirror. This is a diverging mirror. This is a diverging mirror. This is a diverging mirror, okay. So therefore here whatever you do these lines is a not appropriate. Means it is not correct, because that is, as it is a diverging mirror, it is not possible. Then this is not possible. Then how? So if we consider this is coated surface, okay, coated surface, and this is the principal axis, right? So if you consider this is the principal axis, and so reflected rays will be moving in this way, in this way, in this way, or in this way, or else in a straight path. If you retrace the backward, okay, if you retrace the backward, okay, if you retrace the backward, if you retrace the backward, so this one we call it as a, this one we call it as a principal focus, okay, that is the principal focus F, okay. So here you can observe this is behind the mirror, this one in front of a mirror, okay, clear. So for a convex mirror, the principal focus behind the mirror. For a concave mirror, principal focus in front of the mirror. Clear? Right. So next one, let's see. Focal length. What is this, the focal length? What is this focal length? Focal length is nothing but, okay, focal length is nothing but the length from the, okay, length between pole of the mirror to the focus. What is that, a focus? Just we got to know this is the focus of a point, okay. I'll draw one more line, okay, I mean one more diagram. Okay, and this is the principal focus, okay, this is the principal focus, and this is the pole, and the distance between, okay, distance between pole and focus of the mirror, we call it as the focal length, okay. Distance between, or length between focus and the pole of the mirror is called focal length. In the same way in this case, same way in this case, okay. So this is a focal length. The length between pole of the mirror to the focus, we call it as the focal length, okay, right. By definition wise also we can see the distance between pole and principal focus of the spherical mirror is called focal length. And the next one, normal. What is this normal? The line joining, okay, the line joining of point of incidence to the center of curvature. What is that center of curvature? So here center of curvature, okay. So if I consider this is incident ray, okay, let me consider this is the incident ray. This is incident ray, green color, and this is the point of incident, okay, particular case, okay, this is the point of incidence, and this is the center of curvature, this is the center of curvature, and the line joining, okay, the line joining from point of incidence to the center of curvature is called normal, okay. So this one we call it as the normal, this one is normal, clear. Here also same way, point of incidence to the center of curvature, okay. If I consider this is the center of curvature, on this particular case this is center of curvature, then this is the point of incidence, okay, this is the point of incidence. So from here to here, if I consider only one line, or else from here, this is the point of incidence, this is the point of incidence, and this is the normal. So this is the center of curvature, and this is the point of incidence, and this line we call it as a normal, okay, clear. Now let's move on to the next topic, that is the relation between F and R, okay, F and R for the both concave and convex mirror, okay. You see radius of curvature from here to here, okay, radius of curvature from center of curvature to, okay, center of curvature to the pole of the mirror, am I right? So from here to here, okay, this is radius of curvature. You try to understand, this is the focus, okay, this is the focal length, and this is the radius of curvature. You can observe this focal length is half of radius, okay, this is the focal length, and this is the radius of curvature. It is half of radius of curvature. Focal length is half of the radius of curvature, okay, simple. Focal length is half of radius of curvature. Okay. So these are the important terms related to spherical mirrors. Okay. These are the important terms related to spherical mirrors. Now let's move on to the next concept, that is rules for making ray diagrams in a spherical mirrors. Okay. These are very, very important. If we understand this rules for construction of a ray diagram, okay, rules for construction of a ray diagram, it is very, very easy for you to understand formation of image by the spherical mirrors. Okay. So let's see what is the first rule. Object is kept in front of the reflecting surface on its left side. Okay. So if I consider this is a coated surface and this is concave mirror and this is a coated surface and this is a convex mirror, and object should be placed on the left side, means in front of a reflecting surface. Yes, this is the reflecting surface in front. Here also this is reflecting surface in front. Okay, that is the left side. Second rule, the object is always kept on the principal axis such that it is the perpendicular to the principal axis and its foot touches the principal axis. What does that mean? Again, this is a coated surface, this is also coated surface, and these dotted line indicates a principal axis. Okay, principal axis, this is also principal axis. Okay, and here also principal axis, and here also principal axis. Okay, so in front of a mirror, okay, in front of a mirror, perpendicular, okay, in front of a mirror, perpendicular means perpendicular to the principal axis. This is the principal axis, and let's see what is the angle, 90 degree. And here also, this is the principal axis and perpendicular to the principal axis, that is also 90 degree. Okay. So how to place the object is very important. We have to keep the object perpendicular to the principal axis. What if I consider the object is like this? It is not a perpendicular, it is a parallel to the principal axis. Okay, so to make it a perpendicular, what I have to do? Rotate this one, keep on the principal axis. This is what they are saying in the second rule. Okay, now let's move to the third point. Okay, first point it is done. First point it is done. Second point is also done. Third point, for constructing a ray diagram, take at least 2 rays. Okay, it is very important. Okay, minimum 2 rays must be considered. Minimum 2 rays must be considered. Okay, for a convenience whose paths can be traced after reflection. Okay, minimum 2 rays we have to consider, whether that is incident rays or a reflected rays. Incident rays means the rays are striking the mirror. Reflected rays means away from the mirror. So simple incident rays means it is from the object. Reflected rays means it is from the image. It is indicates image. Okay, right. So these are the rules, and let's see what are those convenient rays. They have indicated 2 rays for a convenience, right? How to consider a rays? That we call it as a convenient rays. Means what happens if rays are parallel to the principal axis? What happens if ray passes through the center of curvature? What happens if ray passes through the focus? Okay, so here we have 3 more convenient rays or principal rays. Okay, so here the first point, a ray passing through the center of curvature is reflected along its own path. If we consider this is concave mirror, okay, this is coated surface, this side reflecting surface, okay, and this is pole of the mirror. In the same way for a convex, this is coated surface and this is a reflected surface and this is pole of the mirror. Okay, so according to the condition, okay, so if ray passing through the center of curvature is reflected along its own path, okay, so these are 3 convenient rays are very, very important. Okay, so please remember the first one, if a ray passes through the center of curvature, okay, this is the ray passes through the center of curvature and it is strike the reflecting surface. Okay, and I'll name this one as incident ray. Okay, and after striking, the reflected ray will be retraced the same path, retraced the same path. That means there is no angle of reflection or incidence. Okay, so this is reflected rays. Okay, so this is the ray should be drawn. Whenever there is an incident ray passes through the center of curvature, after striking the surface, it should retrace its own path. Okay, so let's see in case of convex, concave, and this is the convex. So let's try to understand. This is center of curvature. Okay, center of curvature. If a ray of light, in this case, appears to passes through the center of curvature. Okay, appears to passes through the center of curvature, and this is incident ray, and reflected ray will be in a same path. Reflected ray will be in a same path, that is reflected ray. This is the first convenient ray. Whenever the ray is passing through the center of curvature, it retraces its own path. Okay, so let's see the second point, that is a second convenient ray or a principal ray. Okay, so here also say this is principal axis and this is the coated surface for concave mirror, and this is the pole of the mirror, and this is coated surface. On the second point, let's see a ray parallel to the principal axis after reflection either passes, that is in case of a concave mirror, appears to pass through a focus. Appears means that is in case of a convex mirror. Okay, so let's see. This is the incident ray and it is the parallel to the principal axis, you can observe. Okay, so this is incident ray. This is incident ray, and center of curvature means normal for a spherical mirrors. The point which joins the point of incidence to the center of curvature. This is the normal. Okay, so this is the normal. According to the law of reflection, if we consider, this is angle of reflection. Okay, so this is angle of reflection. You can consider it as a reflected ray. Okay, so this is a reflected ray, right? So this is the direction. This is our direction. So whenever the incident ray is the parallel to the principal axis, the reflected ray passes through the focus of a point. Okay, principal focus. You can call it as a principal focus. Actually, it is passing through the principal focus. Okay, in case of a concave. So this is concave mirror. I'll write a name also. This is concave mirror. This is concave mirror. So before that, it is also concave mirror. Okay, so this is convex mirror. Okay, convex mirror and convex mirror. Fine. So let's try to understand this one. Whenever the ray is passing parallel to the principal axis, okay, passes parallel to the principal axis, and this is incident ray. According to the center of curvature, that is the normal, it is passes through the center of curvature from point of incidence to the center of curvature. So according to law of reflection, okay, according to law of reflection, the light ray, okay, appears to passes through the center focus of a point. Okay, so if I consider dotted line, this is the focus of a point. Okay, so this is the focus of a point, right? But it appears means actually it is not passing through the focus of a point, but appears to passes through the focus of a point. Okay, so this is a reflected ray. Reflected ray. Got it? So in case of a concave mirror, actually it is passes through the focus, and in case of a convex mirror, it is appears to pass through the focus of a point. Got it? Now let's move on to the next one. This is concave mirror concave mirror, and this is convex mirror. Okay, right. So again, this is coated surface, and this is the pole of the mirror. This is coated surface, and this is the pole of the mirror. F means principal focus, C means center of curvature, right? So third convenient ray or a principal ray, a ray passing through the focus or appearing to pass through the focus gets reflected parallel to the principal axis. What does that mean? See, whenever the light ray passes through the thickness is too much. Whenever light ray passes through the focus of a point, okay, focus of a point or principal focus, this is the incident ray, and the reflected ray will be parallel to the principal axis. Parallel to the principal axis. Okay. So this is for a third convenient ray. This is reflected ray. And normal passes to the center of curvature. Okay. Which is the line joining point of incidence to the center of curvature. So this is the normal, this is incident ray, and this is reflected ray. Okay. Right. Now in case of a convex mirror, okay, in case of a convex mirror, if it is appears means dotted lines, let's consider dotted lines, okay, appears to passes through the focus, principal focus, it is, this is the incident ray, appears to passes through the focus, it is reflect back, okay, it is the reflect back parallel to the principal axis. Okay, so this is parallel to the principal axis. That is the reflected ray. Okay, and normal, if you draw the point of incidence to center of curvature. Center of curvature. Fine. So these are the three convenient rays which are very helpful in understanding ray diagrams, that is image formation by convex and concave mirror. Got it? Right. Let's see, everything is fine. Yeah. Yes, image formation by spherical mirror. This is the first case. Okay. So let's try to understand. Let's try to understand if I consider a spherical mirror. Okay. So let's consider this is the spherical mirror. This is a spherical mirror. Okay. And let me consider this is axis. What axis? That is the principal axis. Okay. And by the concept, this is pole of the mirror. Okay. This is the pole of the mirror. And this is the focus. That is the principal focus. And this is the center of curvature. And after this dotted line, that we consider it as an infinite. Before this dotted line, this is considered as a principal axis. Okay. And if I keep an object, okay, if I keep an object at different position, so before this dotted line, we call it as the principal axis. And here, if I consider an object, this one we considered as a, okay, this one we considered as a at infinite. Okay, this position is at infinite. This one we considered as a beyond, okay, beyond the C, and this position we considered as a at center of curvature, and this is between center of curvature and focus of a point, and this is at a focus of a point, and this is between focus and the principal, okay, sorry, pole of the mirror. So therefore, how many cases? The first case, and this is second case, third case, and the fourth case, fifth case, and the sixth case. Okay. So we have total 6 cases for image formation by, okay, image formation by spherical mirror, that is a concave mirror. Okay, concave mirror. Fine. The first case, that is at infinite, that is at infinite. Okay, that is at infinite. The first case, that is at infinite. Okay, so infinite means here perpendicular to the principal axis. Okay, perpendicular to the principal axis, and this is the object. Okay, This is the object. Fine. So this is the object O. Object O. So for the first case, you have to consider parallel lines to the principal axis. Okay, parallel to the principal axis. Why? Because it is at infinite. At infinite means the ray of light will always parallel to the principal axis only. Like example, if you consider a sun rays, okay, sun is at far distance, okay, with respect to earth. So rays from the sun we always consider as a parallel to the principal axis. In the same way, let's consider object, this object as a sun at infinite distance. So let's see how image will be formed due to concave mirror. Okay, so first, how many rays we have to consider? First, according to the rules, so we have to keep the object, yes, we have kept in front of a reflecting surface. Okay, in front of a reflecting surface. This is coated surface and this is reflecting surface. Okay, this is coated surface and this is the reflecting surface. Okay, it is in front of a reflecting surface and perpendicular to the principal axis. Okay, this is the principal axis and perpendicular to the principal axis. Second rule, it is also done. And third important rule, that is minimum how many rays we have to consider? Minimum 2 rays. Okay, so minimum 2 rays we have to consider. Minimum 2 rays we have to consider. Okay, so let's consider 2 rays, that is incident rays. Okay, so from the top, this is incident ray and one more at the bottom. Fine, one more at the bottom. Clear? Yeah. So this is incident ray and this is also incident ray. According to the convenient rays, whenever incident ray is a parallel to the principal axis, how does the reflected ray behave? Or else, how does the reflected ray travel? Means through which point it passes through. That is the first point, that is the focus of a point. Okay, so this is the reflected ray through the focus of a point. This is a focus of a point. Okay, so this is a reflected ray. This is also reflected ray, RR. Okay, reflected ray. And here you can observe 2 reflected rays are actually meeting from the beginning. Just remember, if 2 reflected rays are actually intersecting, means that is a real image. Okay, so first what you need to consider, whether the reflected rays are meeting or not, or you can consider whether the reflected rays are actually meeting or appears to meeting. So here 2 reflected rays are actually meeting, that means a real image. So we are talking about the properties of images. Okay, properties of images formed by a concave mirror. Okay, so first point you see position of an image. What is the position of an image? Where does image is formed? How to identify whether image is formed or not? Intersection of reflected rays. Intersection of reflected rays, which indicates image. Intersection of incident rays, which indicates a object. Okay, here it is an object and here it is the image. I'll write it as an image. Okay, now, so position of image is at F. That is, at means of principal focus. Okay, next one, nature of the image. Nature of the image, how to decide whether it is the real image or virtual image? Intersection of reflected rays. If intersection is real, nothing but if the reflected rays are actually meeting, then it is a real image. If the reflected rays are appears to meet, then it is a virtual image. In this particular case, here reflected rays are actually meeting, hence you can consider the nature of the image is real. Real image, okay? Nature of the image is a real image. Next one, type of the image. Type means whether it is the erected or inverted. Already we have seen a nature of the image. If the image is real, it is always inverted. Okay, if the image is real, it is always inverted. If the image is virtual, it is always erected. Okay, so in this particular case, you are not able to see because it is a point size. The image is a point size, very, very small. Okay, so here you can consider a real image is always inverted. Inverted means upside down. Okay, so here you are not able to analyze it in the next case. I'll show you how image is formed. Why we are calling it as inverted. Okay, right. So magnification is nothing but a size. Magnification is nothing but a size. So consider object and image. Size of the object and size of the image. Okay. If we consider size of the image with respect to size of the object, it is very, very small. Just it is a dot. Can I consider it as a point size? Okay, that is a point size. Yes, point size. Okay, so what is the application of this particular case? That is when object is at infinite. So this application used in a doctor's head mirror, metal dish of antenna. Okay, for example, on the top of the building, you are able to see a lot of antennas. Okay, with respect to, you know, broadcasting, or else you can see Tata Skies and all. Okay, so those dishes in the form of a parabola. Okay, parabola. Why? To concentrate all the radiation at a particular point. So all the radiation coming and striking the dish, and all the radiation will be pointed one single point. That is the principal focus. So that will be getting a greater signal. You can say greater signal, or else proper signal will be receiving. Okay, right. So this is the first case. Okay, this is the first case, special case, the formation of images by concave mirror. Okay, now next one, when object is beyond the center of curvature. Okay, beyond the center of curvature. Beyond means just behind this. Okay, let's consider this is a beyond of center of curvature. Okay, so this is object. Okay, so now let's consider incident rays. So always remember, incident rays, one you have to always consider parallel to the principal axis, another one is at any point. Okay, you can consider a next point of that particular position. If we consider this is the position of the object, what is the next position? Center of curvature. Okay, so next point. So first you have to consider incident ray parallel to the principal axis. Okay, parallel to the principal axis. So this is incident ray. Okay, incident ray, and this is the point where it is striked. Okay, so whenever, according to the convenient rays, whenever the incident ray is parallel to the principal axis, it is always passes to the focus of a point. Yes, it is always passes to the focus of a point. Okay, always passes through the focus of a point. Yes. Okay, so this is reflected ray. Fine. Now next one, next incident ray, next point or next point. Let's consider this one only. Okay, next point. Fine. So this is a next incident ray, because we have to consider at least a minimum 2 rays, right? And reflected ray, according to convenient rays, whenever the incident ray passes through the focus of a point, the reflected ray will be parallel to the principal axis. By that concept, you can conclude this is the reflected ray, that is second reflected ray, right? Now, first what you need to understand, the intersection of reflected rays, because we are talking about the properties of images, right? Or else characteristics of images formed by concave mirror. So let's consider intersection. Where is that intersection? Here, intersection. So that means image is formed at this particular position. Okay, so now what you have to do, draw one perpendicular line. Okay, perpendicular line, fine, perpendicular line. So perpendicular line to the principal axis. Okay, this is the perpendicular line, and this is from the principal axis, it is below the principal axis. Okay, so with respect to principal axis, below the principal axis, if I join all these dotted lines, you are able to see image, right? This is the position of the image. Okay, now the first point, position of image, where it is, the image is formed between C and F. Image is formed between C and F. Okay, between C and F. Next, nature of the image. So you have to check whether the reflected rays are actually meeting. Yes, S means it is the real image. Okay, it is the real image. If the image is real, what is the type? It is the inverted or erected? It is always inverted. All the real images are inverted images only. Inverted. Okay, type of images. Next one, magnification, nothing but size. Okay, size. Compare size of the object and size of the image. Comparatively, okay, comparatively, size of the image is smaller than size of the object. That means a diminished. Diminished. Instead of writing a small size, you can call it as a diminished. Okay, diminished. So here I'll write diminished. Diminished is nothing but a small size compared to object. And magnified. Magnified means a bigger in size, bigger in size of the image with respect to object. Okay, now, so I'll show you those simulations also after completing 6 cases. Okay, now let's move on to the next one. When object is at center of curvature. Third case, when object is at center of curvature. Okay, so let's consider center of curvature. Yes, this is the center of curvature, and perpendicular to the principal axis. So this is object. Yes, we know that this is the object. Okay, now, so how many rays we have to consider? 2 minimum. One is always parallel to the principal axis. Okay, parallel to the principal axis. If it is a parallel to the principal axis, a reflected ray passes through the focus of a point. Yes, passes through the focus of a point. Okay, so this is a reflected ray. This is a reflected ray. Okay, fine. Next one, next incident ray, and passes through the focus of a point. Okay, passes through the focus of a point. Passes through the focus of a point. Okay, now let's join means a reflected ray. This is the reflected ray from the mirror. This is the reflected ray, and this is incident ray. Okay, this is incident ray, and this is the point where two reflected rays are meeting. Okay, so here it is the position of the image. Here it is the position of the image. Okay, now what you have to do? Draw the perpendicular to the principal axis. Okay, principal axis. Okay, principal axis, and join all the dotted lines. Okay, join all the dotted lines. Okay, all the dotted lines. Now, after drawing the diagram, what you have to consider? Okay, what you have to consider? This is the coated surface. Okay, it is understood. Now, position of image. Where is the position of image? Same position of the object, that is at center of curvature, that is at C. At C. Okay, at C. Nature of the image means whether that is a real image or virtual image. Let's try to concentrate on reflected rays. What do you need to observe? Whether the reflected rays are meeting or not, or appears to meet. Here you can see two reflected rays are actually meeting. That means a real image. That is real image. And real image is what type of image? It is an inverted type. Okay, inverted. And magnification, if we observe, the size of the object and size of the image is same. Same size. Okay, same size. Size of the image is same size as object. Okay, what is the application? That is behind the projector lamp. Okay, behind the projector lamp. Okay, now let's move on to the fourth case. That is a fourth case. What is fourth case? When object is between center of curvature and focus. Let's see. Center of curvature and focus. Okay, center of curvature and focus. This is the object. Yes, of course, we know that. Okay, so this is object. So perpendicular to the principal axis. What is the convenient ray? Here you need to consider two rays. Okay, we need to consider two rays. One is always parallel to the principal axis. Okay, yes sir, parallel to the principal axis, and it is the parallel to the principal axis, that is incident ray. Okay, now when a ray is a parallel to the principal axis, the reflected ray passes through the focus of a point. Yes, passes through the focus of a point. Okay, so this is a reflected ray. This is a reflected ray. First ray, it is done. Second one. If I consider second one, so let's consider passes through the focus. Okay, passes through the focus. This is the second incident ray. And whenever the ray, incident ray passes the focus, it is always parallel to the principal axis. Always parallel to the principal axis according to the condition. I mean, principal rule. I mean, principal rays. Okay. So this is the point where two reflected rays are meeting. Okay. Two reflected rays are meeting. And whenever the two reflected rays are meeting, that is the position of the image. Okay. So after finding out a point, what you need to do? A dotted line perpendicular to the principal axis. And what do you have to do next one? Join all the dotted lines. Okay. Join all the dotted lines. Okay. And this is image and this is image and that is object. Look at the diagram carefully. Okay. So first you need to know whether the two reflected rays are meeting or not. Yes, of course. Two reflected rays are actually meeting. Okay. Two reflected rays are actually meeting. That means it is the real image. Fine. So position of image behind C. Okay. Behind C. And in nature of the image, two reflected rays are meeting, therefore it is a real image. And nature, as it is a real, it is inverted. Inverted means upside down, because it is the position of the object and this is the position of image. Upside down. Upside down only, we are calling it as an inverted image. Okay. So this is inverted. Okay. Inverted. Next one, magnification. Consider size of the object and the size of the image. Compared to the size of the object, the size of the image is bigger. But you cannot write a bigger. Instead of that, you can use another word, that is a magnified. Okay. So here you can consider it as a magnified. Okay. Magnified. And where do we use this kind of, case in our day-to-day life? That is a floodlights. Like a cricket stadium, you see, right? In a cricket stadium, you see a big, poles of a light. Okay. Where day and night match is going to happen. Okay. So generally you can consider not only cricket, you can consider any ground. So where this application of a mirrors will be used. Right? Now, next one, that is the fifth case. When object is at the focus. Object is at a focus. Okay. At a focus. Fine. This is the object. Okay, sir. This is object. Okay, sir. How many convergent rays we have to consider? Two. The first one, incident ray parallel to the principal axis. Okay. Yes, of course. This is the parallel to the principal axis. Parallel to the principal axis. This is incident ray. And whenever it is a parallel to the principal axis, reflected ray, it is passes through the focus of a point. Okay. Focus of a point. Done. And the next one, obliquely. Obliquely means according to the law of reflection. So let's consider this is incident ray. Okay. This is incident ray. And reflected ray at the same angle. Okay. At the same angle you can consider. At the same angle you can consider. So here, this is a reflected ray, first reflected ray, and this is the second reflected ray. And you need to identify whether the two reflected rays are meeting or not. Yes, it is a meeting. Okay. So what do you have to do? Perpendicular line to the principal axis. Okay. So this is the image. This is image, position of the image. Okay. Now, try to understand first one obliquely. Okay. So whatever the angle of incidence, that will be the angle of reflection. Now, the first one, position of image, where it is. So if it is here, you can call it as a behind C. But it is, you can see, these two rays are meeting behind C only, but it is too far. Okay. Too far means you can consider it as a at infinity. At infinity. Next one, nature of the image. Two reflected rays are meeting. Okay. Two reflected rays are meeting. Then you can call it as a real image. Real image. And the nature, inverted. A real image is always inverted. Okay. Next one, magnification. Highly magnified. You see, height of the object and height of the image. Highly magnified. Highly magnified. Highly magnified. And application, torch is car headlights and searchlights. Okay, so car headlights, not a mirror. Okay, it is car headlights and searchlights. Okay, and the next one and the last case with respect to a concave mirror. Okay, yes. So the condition is when an object is placed between focus and the pole. Okay, so let's consider object. Fine, object. Yes, object. This is object, and we have to consider two incident rays. Okay, this is first incident ray, and if we consider incident ray, this is incident ray, and reflected ray will be parallel to the principal axis. Okay, sorry, passes through the focus of a point. Okay, passes through focus of a point. So this is a first reflected ray. Okay, first reflected ray, and the next one, next obliquely. Obliquely, this is second incident ray. But this is a second incident ray. Okay, so this is a reflected ray. Okay, this is reflected ray. This is second reflected ray. And here you can observe clearly these two rays are diverging. Diverging rays cannot meet even at infinity. Okay, so that two reflected rays are not meeting. Therefore, what is the another method? That is retracing backward. Retracing backward means like this. Retracing backward. Retracing backward. Retracing backward. So this is where two reflected rays appears to meet. They are not actually meeting. Okay, these are the two reflected rays. But if we retrace backward, means behind the mirror, they appears to meet. So this point we call it as a position of image. What do we have to do? Perpendicular line. Draw the perpendicular line. Okay, and in place of head and a tail with a tail. Okay, so this is image. Okay, now first what you need to observe, reflected rays, are they meeting? No, but appears to meet. Therefore, position of an image behind the mirror, behind the mirror, behind the mirror, behind the mirror. Okay, and nature of the image, you see this is the object and this is the image, same as it is. Okay, same as it is means if the image is above the principal axis, then you can call it as a erected. If the image is below the principal axis, you can call it as a inverted. Okay, as it is above the principal axis and same as it is, you can call it as a erected. Okay, nature, it is a virtual. Why it is a virtual? Because two reflected rays are not actually meeting but appears to meet behind the mirror. Therefore, it is a virtual image. And virtual image is always erected. Okay, erected means upright. And magnification, you see, it is a magnified, means the size of the image is bigger than size of object. Where do we use this one? Application, dentist mirror, makeup mirror, and shaving mirror. Okay, to see ourselves, okay, to see ourselves, okay, we use a concave mirror in a bigger picture. Okay, so at our home also we use to shave. Okay, so this is the application and this is the last one. So here one question. Okay, you need to observe carefully this concave mirror in all the 6 cases. Okay, if you consider all the 6 cases till 5th case, that is from infinite to the focus of a point, that is a principal focus, it produces a real image and inverted image. It produces, you know, a diminished image as well as a magnified image. Okay, but the same concave mirror produces a virtual image and it is a bigger than a object. That is the magnified image it will produce. Virtual image only, but it produces a magnified image. Okay, So in examination, they can ask you which mirror produces both real and virtual image. You have to say that is a concave mirror. Okay, clear? Let's see. Next one. I want to show the simulation, but it is not possible. Let's move on to the next topic, that is image formation by spherical mirror. Here in this particular case, it is a convex mirror. Okay, convex mirror. So this is coated surface and object at infinite. Okay, let's consider at infinite. Object is at infinite. Okay, object is at infinite. This is object. This is object, and we have to consider two incident rays. One is from the top, another one is from the bottom. Okay, so these are incident rays. The first one, incident ray, and this is also incident ray. So when the incident ray is parallel to the principal axis, in case of a convex mirror, reflected ray appears to pass through the focus. That is the principal focus. Okay, so appears means like this, and this one like this. Okay, fine. Now this is where image will be formed. This is where image will be formed, and reflected rays will be moving this way, and the second one this way. Okay, so this is reflected ray. This is diverging mirror, no? So that is the reason they are moving away. They do not meet actually, therefore retracing backward. So here they are meeting, that is the position of image. Okay, and by the characteristics, if we observe the diagram, what are the characteristics of the image formed by convex mirror? Okay, so here the first point, position of an image. Okay, position of an image at focus. At focus, that is the F. Nature, as the two reflected rays are not meeting, therefore it is a virtual, but appears to meet. Okay, virtual image is always erected. Clear? Magnification just a point size. Point size. Okay, and where do we use? Street lamps. This application used in our street lamps. Okay, right. Next case, that is the next case, when object is between infinity to pole. Okay, infinity and a pole. Okay, so if I consider this is the pole and this is infinite, between infinity and the pole of the mirror, we keep anywhere on the principal axis, it is always produces a diminished image only, and virtual. Okay, so if we keep object anywhere in between, okay, here I'll keep object. Okay, and this is object. How many rays we have to consider? Two rays. So incident ray, one is parallel. So if it is a parallel, it is always appears to passes through the center of focus of a point, right? Focus of a point. So this is a reflected ray. This is a reflected ray, and in the same way here. Okay, so pole of the mirror, if we consider, okay, pole of the mirror, if we consider, it will reflect back. It will reflect back. So this is reflected rays, and these are incident rays. Okay, these are incident rays. Got it? And here you can see these two reflected rays do not meet, therefore you can retrace backward. Okay, retrace backward. Retrace backward, here the two reflected rays appears to meet, and this is the position of the image. Position of the image. This is the position of the image. Okay, image will be lying between pole and the focus of a mirror. Okay, pole and the focus of a mirror, and the position of the image between P and F. Okay. And the nature of the image, as two reflected rays are not meeting, therefore it is a virtual image. It is virtual image. Okay. And the type of image, virtual means it is always erected only. It is always erected only. And magnification, if you see, size of the object and size of the image. Size of the image is smaller than size of the object. Okay. Therefore, magnification, it is a magnified. Instead of a magnified, small, what you have to write? It is a diminished. It is always a diminished. Okay. And application, rear view mirrors. Okay. This one you can expect in the examination. Okay. This one you can expect in the examination. Rear view mirrors in our vehicles and used as shop security. Okay. That is a convex mirror. Okay. Convex mirror. Fine. So these are the important applications and image formation by a spherical mirror, that is both the concave mirror as well as a convex mirror. Okay, got it? Right. Fine. And here you need to understand what is the difference between convex and concave mirror. Concave mirror produces both real as well as virtual, but the convex mirror produces only virtual images, not real images. Here one more difference. Concave mirror also produces a virtual image and a convex mirror is also produces virtual image. But what is the difference? Concave mirror produces a virtual image, but it is a bigger than size of the object. That is a magnified virtual image. But in case of a convex mirror, the virtual image is diminished compared to the size of the image. Okay, size of the image to the size of the object, it is very small. Diminished image in case of a convex mirror. Okay, so this is the difference between virtual image formed by concave mirror and convex mirror. Got it? Okay, now let's move on to the new Cartesian sign convention. Okay, new Cartesian sign convention. What is this? So remember coordinate system. Okay, instead of that graph, you can understand here. Okay, so this is y-axis, we know that, and this is x-axis, and this is minus y-axis, and this is minus x-axis. Okay, and this is the origin. So try to understand distances in this direction, positive, right? Height in this direction, positive, right? Distances in this direction, negative. Distances in this direction is a negative, because we are taking origin as the reference point. Distance measured from origin along this side positive, along this side positive, and along this side negative, along this side negative. Okay, the same thing they have given here. Okay, so let's see. So this is the pole of the mirror. Pole of the mirror considered as the origin. Left side, if we measure a focal length and object distance, it is always a negative. And image can be positive or a negative. Okay, image, if it is formed in front of the mirror, okay, that means it is a real image, so it is a negative. If the image is formed behind the mirror, that is a virtual image, it is a positive. That's all. Okay, so you please go through the important important points. Okay, see the first point, the pole of the mirror is chosen as the origin of the coordinate system. Okay, second point, the object is considered to be placed in on the principal axis to the left side of the mirror. Therefore, object distance is always a negative. This is always a negative. Okay, this is always a negative. The third point, all the distance are measured along the principal axis from the pole of the mirror. Okay, the distance of the object from the mirror is denoted by u. Okay, this u nothing but object distance. Okay, pole of the mirror, u. Distance of the image from the pole is measured by the v, and the focal length f. Okay, so if you see the diagram, okay, so concave mirror, you see u is the negative, v is also negative if image is a real. Okay, and v is positive if image is virtual. Virtual means the image will be formed in this way, this side. So from the pole of the mirror to this side, it is always a positive, alva? Positive. This side is a positive. Okay, getting my point? Next one. Focal length. Focal length nothing but the distance between focus and the pole of the mirror. So this side, if it is this side, what is the f value? F is a negative. Focal length of a concave mirror. Okay, focal length of a concave mirror, it is the negative. And in this particular case, okay, in this particular case, U, it is always a negative, and V, it is always a positive, because image will be formed this side. Okay, image will be formed this side in case of a convex mirror. And the next one, focal length. Focal length is also distance between pole and focus. Okay, distance between pole and focus, that is nothing but it is also positive. Okay, so these sign conventions are very important in a solving numericals. Okay, solving numericals. Okay, so let's move on to the next concept. Distance measured in the direction of incident ray are taken positive, while distance opposite to the direction of incident ray taken negative. Okay, this is not required. So what I have given in the previous slides, that is more than enough. Okay, more than enough. Now let's move on to the mirror formula. What is this mirror formula? We have a distances, right? What are those distances? Image, object distances, object distance, image distance, and a focal length. If we have a relation between focal length of the mirror and V means object distance, V means image distance, U means object distance. The relation between object distance, image distance, and focal length respectively, we call it as a mirror formula. Okay, you see, a formula which gives the relationship between image distance, object distance, and focal length of a spherical mirror is known as mirror formula, and it is given by, okay, it is given by 1 by F, that is equals to 1 by V plus 1 by U. Okay, and these formulas, okay, these values, F value and V value and U value, always substitute with respect to sign. Okay, with the sign you have to substitute. Fine. Next, magnification. So magnification is nothing but a size comparison. Okay, maybe it is the height wise or else a distance wise. How? If I consider a magnification with respect to distance, that is object distance and image distance, ratio of image distance to the object distance, it is also called magnification. And there is one more method to calculate or to know the magnification of an image, that is height wise, height of the image to the height of the object. Okay, two ways we can decide. The ratio of the height of the image to the height of the object. So magnification, it is given by small letter m, it is given by minus v, so height of the image, right, h I, and height of the object ho. Okay, it is divided by ho. Okay, and in another way, okay, the ratio of the distance of the image to the distance of the object, that is nothing but with a negative sign. Okay, v divided by u, that is m is equals to hi divided by ho, that is with respect to height wise, this is distance wise, image distance to the object distance. Okay, and combining both the formulas, okay, m is equals to hi divided by ho minus v divided by u. This one we call as a magnification, right? So here magnification, okay, here magnification, yeah. So very important point, if m is positive, okay, if m is a positive for virtual image, if m is negative means virtual image, and if it is negative, if it is the negative, then it is the real image, it is a real image. Okay, and the next one, if m is equals to 1, that indicates same size. Okay, same size. If m is equals to, okay, m is greater than 1, means the size, if it is greater than 1, magnification is magnified, means bigger in size. Okay, if m is less than 1, that indicates diminished image. Okay, diminished image. Getting my point? So in one way, if I write magnification, it is nothing but plus or minus n. Okay, plus or minus n. Plus or minus indicates, okay. So plus or minus indicates nature of the image. Nature of the image. Nature of the image. So if M is a positive, that indicates a virtual image. If M is a negative, that is the real image. And here, size. N means the size. Okay. N means 1. We are considering 1. Okay. If N is greater than 1, that means magnified. If N is less than 1, means diminished. If M is equals to 1, means the same size. Okay. Right. Next one. Okay. Questioning part. NCERT exercise questions. 9.1. A convex mirror. First, you need to identify what type of a mirror they have given. Okay. Convex mirror. Okay. For a rare wave on an automobile has a radius of a curvature. So first what we need to do? First we need to write down data. Radius of a curvature, that is 3 meter. Okay. If a bus is located at a 5 meter, bus means it is the object distance, it is a negative because in front of a mirror, right? So 5 minus 5 meter, and radius is also negative sign, okay, because it is in front of convex, right? So convex they have given. So convex mirror, radius will be positive only. Okay, so that is 3 meter, and object distance is always the negative, that is a 5 meter. Okay, it is in front of a reflecting surface, right? Next one. Find the position, nature, and size of the image. Okay, position means V value, and size means magnification, and size of the image. Nature means if M is a positive, then it is a virtual. If M is a negative, then it is a inverted. Not inverted, virtual. If M is a positive, virtual. M is a negative, means real. Okay, so here, if M is positive means virtual, M is negative means a real image. Okay, right. So from the formula, okay, what is that formula? Mirror formula. Okay, mirror formula. Okay, so before mirror formula, we need F value, right? If I write F, 1 by F is equals to 1 by V divided by 1 by U. We don't have a value of F, but we have relation between F and R, right? F is given by R divided by 2, half of the radius, that is 3 by 2. Okay, 3 by 2 meter. So substitute here. So 1 divided by 3 by 2, that is equals to 1 by V. We need to calculate, plus 1 by U value, that is the minus 5. Okay, so simplification. So can I write this 1 divided by 3 by 2 as a 2 by 3? And this is the plus into minus minus. If I send that 1 by minus 5 to the left hand side, it becomes a positive 1 by 5. That is equals to 1 by V. Okay, so here 1 by V, that equals to, so take the LCM, that is, so 5 to the 10 plus 3 divided by 15. Okay, so that is 13 divided by 15. So V is equals to reciprocal 15 divided by 13, and V equals to, okay, so V equals to, so calculator, so 15 divided by 13, that is 1.15 meter. Okay, so here only you can conclude that V is the positive. When are you getting this image distance as a positive? Behind the mirror. Behind the mirror means it is a virtual image. Okay, so here as V is a positive, it is a virtual image. Okay, there is another method to find out whether it is a positive or negative, means whether the image is a real or virtual, using magnification. Okay, so next question, what they've asked, find the position. Position is clear, that is 1.15 meter. Nature, that is a virtual. Size means the size of the image, that is magnification you can consider, or else so magnification, that is nothing but minus V divided by U. V value, here you can consider V value minus 15 divided by 3 into 1 divided by U value, U, that is a minus 5. Okay, so here you can see minus minus get cancelled, 5 ones are 5 threes are, right? This one is 13, right? 3 by 13. 3 by 13. So 3 by 13, that is 0.2. Here M is positive 0.23. So from here also you can identify whether it is a real image or virtual image. Okay, so as M is a positive, it is a virtual, and as it is the less than 1, okay, as it is the less than 1, it is a diminished. It is a diminished. Okay, clear? Now let's move on to the next question. Next question, yeah. So that is 9.2. An object 4 centimeter in a size. Okay, object the height they have given. Object height HI, that is 4 centimeter. It is always positive. Okay, because it is on the principal axis, right? Positive 4 centimeter is placed at a 25 centimeter in front of a concave mirror. Okay, so concave mirror they have given. Concave. So object distance, it is U is equals to minus 25 centimeter. Okay. Focal length, for a focal length of a concave mirror, that is the negative 15 centimeter. Okay. Now, at what distance from the mirror should a screen be placed in order to obtain a sharp image? So your screen is nothing but to obtain an image, right? So that is nothing but a position of the image only. Therefore, here we need to calculate V, and nature, that means M value, and the next one, size of the image, that is nothing but HI. This is HO. I have written HI, that is wrong. Okay, so that is HI. HI we need to calculate. So here HO, size of the object. Okay, size of the object. Okay. So first, mirror formula. Mirror formula. Okay, so from the mirror formula, 1 by F, that is equals to 1 by V plus 1 by U. Okay, now substitute the values. 1 by F, what is the value? That is minus 15 centimeter. That is equals to 1 by V plus 1 by U value, that is minus 25 centimeter. Okay, so 1 by V is equals to, so plus into minus minus. Okay, plus into minus minus. If you send this 1 divided by minus 25 to the left hand side, it becomes a positive. That is 1 divided by 25 minus 1 divided by 15. So simplification, 1 by V, that is equals to LCM. If you take, okay, LCM 75. Yes, 75. 3 is a minus 15 5 15 50, yeah, 15 5 75. So this is 75. That is nothing but minus 2 divided by 75. Okay, so V equals to minus 75 divided by 2. So that is nothing but minus 34.5. Okay, 60 65 60 35 means it is a 75. Okay, it is not 34, 37.5. Okay, 75 divided by 2, that is 37, right? It is 37.5 centimeter. Okay, so V value, it is a negative 37.5 centimeter. As it is a negative, that indicates it is in front of a mirror. Okay, in front of a mirror means it is a real. It is a real image. It is a real image. Okay. Or else you can take help from the magnification. Okay. So let's find out a magnification. Minus V divided by U. Minus V how much? Minus V, that is minus of minus 75 divided by 2 into U value minus 25. Okay. Minus 25. So here you can see negative, negative, negative into negative, positive, and positive into negative, negative only. So M is the negative. And what about this one? So 75 divided by 75 divided by 2. 75 divided by 25, that is 3 by 2. Okay, 3 by 2. That is nothing but minus 1.5. So magnification, it is minus 1.5. Okay, minus 1.5. So here negative sign indicates it is a real image. Okay, so negative sign indicates a real, plus as it is greater than 1. Okay, 1.5. As it is greater than 1, it is a magnified. It is a magnified. Simple. Okay. And what they've asked? Size of the image. Size of the image, nothing but HI. Okay. HI. So magnification, HI divided by HO minus V divided by U. Okay. So HI value we need. Therefore, minus V divided by U into HO. Okay. Substitute the values. HI, that is equals to minus 75. Minus 75 divided by 2 into 1 divided by 25 into HO. HO 4 centimeter. Okay. So 4 centimeter. Okay. Now, so HI, that is equals to, this is also negative, negative only. So negative. So 25, 3 by 2. 3 by 2. And here you can see 2 1s are 2, 2 2s are 4. And HI, that is equals to minus 6 centimeter. Okay. Height of the image is negative, means it is below the principal axis. Okay. It is the below the principal axis. So below the principal axis means it is the real image, and size of the image is greater than size of the object. Okay. So before moving on to refraction part, so let's try to understand the formation of images by concave and convex mirror. Okay. So here we have some simulations part. Okay. So let's try to understand image formation. So first I'll consider concave mirror. Okay. So position of the object infinite. Okay. So let's consider position of the object at infinite. Okay. So this is the first focus. Okay. This is the first focus, or else you can call it as the principal focus. Okay. So if I consider object, if it is at infinite, okay. So what is the image characteristics? So let's try to understand considering principal rays. Okay. Principal rays. See. So this is, image formed, but it is the inverted because it is vertically downward. Or else you can say it is below the principal axis. So first case, when object is at infinite, what are the characteristics of the image? The first one, it is, what is the position of image? It should be at a focus of a point. Okay. Principal focus. But actually it is not at infinite point. Okay. Actually it is not at infinite point. Okay. It is not at infinite point. So that is the reason the image is formed just beyond the focus. So now let's try to understand the position of the object beyond the C. So when the position of the object beyond the C, what is the position of the image? That is between a center of curvature and the focus of a point. Okay. Now, third case, when object is at center of curvature. Okay. This is the center of curvature. So when object is at a center of curvature. Okay. So here you'll see. So this is object and this is the image. Okay. This is the object and this is the image. Fine. So this is object and this is the image. Getting my point? So here if you want, this is the object and this is the real image. Now, between F and C, this is the object and this is the image. So what is the position of the object between C and F? What is the position of image behind the C? That is center of curvature. And in nature, it is the real image because it is below the principal axis and inverted. And coming back to the magnification, it is the magnified compared to the size of the object. Here size of the image is more. Okay. And the next one, F. Okay. On F, that is a focus of a point. So here you can see the two parallel lines. Okay. Two parallel lines. Just assume that these parallel lines going to meet at infinite point. Okay. If two reflected rays are meeting at infinite point means that is the position of image. That is at infinite. So if two reflected rays are meeting, what does it mean? It is a real and inverted image. And magnification, if you see at infinite means it is highly magnified. Okay. So let's see the last case between F and P. That is the pole of the mirror and the focus of a point. Okay. So here you can see the two rays are diverging. That means the two reflected rays cannot be intersecting. Okay. So that if I retrace backward, that is behind the mirror, here you can see dotted lines. So here two reflected rays appears to meet. So that is the position of image. Okay. Now compare the size of the object and size of the image. It is a magnified. Okay. And two reflected rays are not meeting but appears to meet. So virtual image and virtual image is erected. Okay. So these 6 cases with respect to concave mirror. Fine. Now with respect to convex mirror. Okay. With respect to convex mirror. Now object is at infinite position. Okay. Object is at infinite position. You see. Okay. So let's see image. Where does it form? Because you can see reflected rays do not meet because it is a diverging mirror. So reflected rays cannot be meet. Okay. Cannot be meet. So if I consider virtual image, you see size of the object and size of the image. It is the diminished. And also between focus and pole of the mirror. If I move this object towards the mirror, and here you can see the image distance decreasing, means moving towards the pole, but it cannot be greater than size of the object. Okay. So here you can conclude that in case of a convex mirror, okay, in case of a convex mirror, the size of the image, it is a diminished and virtual. Okay. And erected. Getting my point? Now let's move on to the next topic, that is refraction. Okay. That is refraction. Okay. So before moving on to the topic refraction, let's try to understand. Okay. Let's try to understand optical medium. Optical medium means it is nothing but transparent medium. Okay. So first of all, reflection means bouncing back of light ray into the same medium. Okay. But what about refraction of light? Refraction of a light, which indicates the change in direction of a light when it is traveling from one medium to another medium. In case of a reflection, the light do not pass through from one medium to another medium. But in case of refraction, the light can travel from one medium to another medium. That is one optical medium to another optical medium. So in simple word, we can say that the refraction of light is nothing but change in direction of light when it is traveling from one optical medium to another optical medium. Okay. And here optical medium. Okay. If we talk about a state of matter or else a state of substance, we say solid, liquid and gaseous state. But here we are talking about optical medium, that is a transparent medium. So in transparent medium, or you can say optical medium, there are two types of a medium with respect to propagation of a light. So that is the rarer medium and denser medium. Okay. So let's try to understand what is a rarer medium and denser medium. Okay. So before that, the refraction of light, the phenomena in which light ray changes its direction when it is traveling from one optical medium to another optical medium. So what is the reason why the direction is changing? Why the direction of light ray changes when it is traveling from one medium to another medium? Okay, so to answer that question, to answer such question, here first we need to understand what is optical medium and what are its type. Okay, so first if you see optical medium, okay, it is divided. Optical medium nothing but transparent medium. Okay, so first one rarer medium and the second one denser medium. The word only indicating rarer and denser. So denser, density, it is a mass per unit volume. Okay, so mass per unit volume, it is a mass density. In the same way, if we consider optical mediums, transparent mediums, for example, solid, if I consider, what is the optical medium for a solid? That is a glass slab you can consider. Okay, what is the example for a liquid medium? That is the water is the transparent medium, nothing but optical medium. If I consider a gas state, okay, gaseous state, what is the example? Air medium. So air, water and glass medium are the perfect example for optical medium, nothing but the propagation of light in a mediums. Okay, so let's try to understand rarer and denser medium with examples. Okay, so denser medium, okay, the word only indicating dense. Okay, so here what happens? So let's try to understand. There are two roads. Okay, there are two roads, identical roads, and here situation is the first case, first road and a second road. In a first road there is a traffic. There are traffic, nothing but there are more number of vehicles are moving. In a second road, okay, second road there is nothing because it is completely empty road. Okay, and you and your friend, riding your bicycle. Okay, and you need to understand, if you and your friend starts from same position but in two different road, okay, to reach 100-meter distance, who will take less time? Just think and answer. Okay, one is crowded road, another one is empty road. You are traveling in the crowded road and your friend is traveling in a empty road. You both have to cover 100-meter. Who will reach faster? Your friend, definitely, because there is no traffic, because it is completely empty. So you can understand there is no obstacle for your friend, but you have obstacle, that is the crowd. Okay, there are more number of vehicles. Okay, your speed will be less, therefore you cannot travel fast. So if I consider empty road is nothing but, a rarer medium, the first road in which you are traveling, that is nothing but a denser medium. So you and your friend is nothing but a light. Okay, now here simple, when a speed of light, okay, if a speed of light is decreasing in a medium, so that medium is called a denser medium. And rarer medium, the medium in which the speed of light increases. So just we are talking about the speed of light. Speed of light, based on that we have differentiated two mediums, optical mediums only. Okay, the medium in which the speed of light increases, then that medium is called a rarer medium. The medium in which the speed of light decreases, then that medium is called denser medium. Okay, so here you can see the transparent medium in which the speed of light decreases. Okay, so let me consider example. Okay, so this is molecular model basis explanation. Okay, once again, So all these are molecules. This is first medium. Okay. So this is first medium. Okay. And this is second medium. First medium and second medium. So here you can see this particular medium, the density is less because here more number of, compared to the second one, here less number of molecules are occupied in a same amount of volume. But here in a same amount of volume, there are more number of particles occupied. Therefore, in this particular case, this is less denser and this is more denser. So I can say this is a denser medium and this is a rarer medium. Okay. So this is a rarer medium and this is a denser medium. Okay. This is the denser medium. Okay. So here if I consider an example, the speed of light reduces. Okay. In this particular case, first and second case, if I consider, here speed is more. But what about here? Speed of light will be less because it is denser medium. At the same time, if we consider rarer medium, again it is a transparent medium in which the speed of light increases. What does that mean? Okay. All these are molecules and this is the one state or else one medium and this is another medium. Now tell me, what happens to the speed in this case and what happens to the speed of light in this particular case? So here speed of light decreases because of more density, and here you can see because of less density the speed of light is more. Okay, so simple. Denser medium, the speed of light reduces or decreases. In a rarer medium, speed of light increases. Okay, so based on this rarer medium and denser medium, we are going to answer why speed of light, okay, the direction changes or speed of light changes. Okay, now cause of refraction. Okay, cause of refraction. When a ray of light passes from one medium to another medium, okay, its direction or path changes because of change in a speed of light. Okay, change in a speed of light. That's all. Okay, change in a speed of light. So when we are talking about speed of light, the first one in an air medium, speed of light, that is the 3 into 10 power 8 meter per second, and in water that is the 2.5 into 8 meter per second. In some textbook they have given 2.25 into 10 power 8 meter per second. Okay, and glass medium it is the 2 into 10 power 8 meter per second. Okay, so comparison. Okay, comparison, if I consider comparison between water and air. Okay, water and air, which one is rarer and which one is denser? Okay, which one is rarer and which one is denser? By density concept, by density concept, we know that. Okay, so water is the denser medium. For a ray of light, okay, speed of light in a water decreases, but in speed of light in an air medium increases. That means it is a denser and this is rarer medium. Okay, and the next one, next example if I consider, okay, next example if I consider water and a glass slab. Okay, water and a glass. Water and a glass. In water, with respect to these two, which one is a rarer medium, which one is a dense medium? Okay, so here speed of light increases. In this case, speed of light decreases. Comparatively, okay, comparatively, this is the rarer medium and this is the denser medium. Okay, this is the denser medium. So like that. Okay, it is depends on pair of the medium. You see, the first pair, water is a denser medium and air is the rarer medium. For the second pair, water is a rarer medium, glass is the denser medium. Okay, it depends on a pair of medium. Okay, so that we can decide which one is a rarer medium and which one is a denser medium. Okay, right. Next one. Yes. So refraction, okay, refraction, that is nothing but a change in direction. You can call it as a deviation of a light ray. Fine. The first case, refraction from rarer to denser. So rarer to denser. So here I'll consider one small example. Okay, let's consider air and water pair. Okay, air and water pair. So let's consider rarer medium to denser medium. Therefore, here I'll consider air and water. Air and water. So here I'll consider this is incident ray. Okay, this is incident ray. This is point of incident. Okay, so that is point of incident. This is incident ray. From point of incidence, if I consider perpendicular to the surface, which is separating two media. Okay, if there is no medium, means single medium. If there is no surface at all which is separating two media, for example, it is completely air or else it is completely water, the light would have traveled in a same direction. The light would have traveled in a same direction. But here there is a medium which is separating two medium. Means there is a surface which is separating two medium, air to water. So here you tell me what happens to the ray of light. Definitely it will change its direction, but towards or away from the normal. So as it is traveling from rarer to denser medium, definitely speed of light decreases. So when speed of light decreases, it will bend towards the normal. Okay, it will bend towards the normal, and this is refracted ray, not reflected ray. Okay, this is a refracted ray, bends towards the normal. Okay, so here you can see refracted ray. Okay, refracted ray bends towards normal. Okay, and one more example. Here I'll consider example glass. Okay, here I'll consider glass, and here air. Okay, when the light is traveling from glass medium to incident ray, and this is point of incidence. From point of incidence, that is the perpendicular drawn to the surface which is separating to two medium. And if there is no surface or else single medium, the light would have traveled in the same direction. But here there is a medium, right? So there is a medium, and this is the normal. And here, as it is traveling from glass medium to air medium, definitely in the second medium, speed of light increases. Why? Because it is a rarer medium. So refracted ray bends away from the normal. Okay, refracted ray bends away from the normal. Okay, bends away from the normal. Okay, so here refracted ray bends away from normal. Away from normal. Okay, so this is normal and this is also normal. Fine. Next one, refraction at a normal. Refraction at a normal means there are two mediums. Okay, we know that there are two mediums. Let's consider this is incident ray. Okay, this is incident ray, and this is point of incidence, and normal will be perpendicular to the surface. Yes, perpendicular to the surface. The light would have traveled in the same direction. Okay, here there is a refraction, but what happened? But there is no change in direction of light. Okay, change in direction of light. There is no change in the direction of light. So when it will not change the direction means when light incident on the surface normally. Okay, normally. So then there is no refraction. Means there is no change in the direction of light ray. Getting my point? Okay. So these three conditions are very, very important. They'll ask you in a board exam, like when a ray of light is traveling from rarer to denser medium, how does a refracted ray bends away or towards the normal? So when light ray traveling from rarer to denser, refracted ray bends towards the normal. When a ray of light traveling from denser to rarer medium, then the ray of light, that is a refracted ray, bends away from the normal. And what is the condition where there is no change in the direction of incident rate light? Then that is the 90 degree. Okay, when ray of light strikes the surface normally. That is nothing but 90 degree. Okay, right. So next one, laws of refraction. Similar to the okay, similar to the law of reflection only. Okay, so let's consider this is the surface which is separating two media. Okay, so this is surface which is separating two media. Surface which is separating two media, and let me consider this is incident ray. Okay, this is incident ray, and this is point of incidence. From point of incidence, this is a normal. This is normal. Okay, and if there is no surface, the light ray would have traveled in the same direction, but here there is a medium which separating two, sorry, there is a surface which is separating two medium. Okay, now, so let's consider this is a air medium. Okay, this is air medium and this is glass medium. Definitely the ray of light bends towards the normal. Okay, towards the normal, and this one refracted ray. Okay, now, like angles we have discussed in a case of a reflection, in the same way here also, angle between normal and incident ray, that is angle of incidence. But in case of refraction, the angle between normal and refracted ray, that is nothing but angle of refraction. Okay, so using same diagram, we have a two laws of refraction. The first one, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given pair of media. This is first media and this is second medium. This law is also known as Snell's law. Okay, by the statement we can conclude that sine of angle of incidence divided by sine of angle of refraction, that is equals to constant, and this constant only we are calling it as a mu, nothing but refractive index. Okay, this is the refractive index. And second part, that is similar to the law of reflection, that is nothing but incident ray, normal and reflected ray all lie in a same plane. Just replace reflected ray with a refracted ray, the same statement. Okay, the same statement. The incident ray, normal and refracted ray at a point of incidence all lie in a same plane. Got it? Okay, so simulation wise I'll show you. So this is done. Next one, yeah, you see this is the light ray. Okay, so I'll switch it on. You see, if this is the air medium, okay, both are air medium, see, light would have traveled in the same path, direction of incident ray. Okay, because same mediums. Okay, refractive index is same, so that is the reason the light ray is traveling in the same straight line. What if this is a air medium, the second one glass medium? You can see the light bends towards the normal. Okay, now this is the rarer medium, denser medium. So as it is traveling from rarer medium to denser medium, you see speed of light. Is it possible to check speed of light? 1 second. Intensity we can check. No, only intensity we can check, right? Yes, speed we can check now. Okay, angle. Now speed, you see this is the rarer medium in the first case. See 1c, c means 3 into 10 power 8 meter per second. Okay, speed of light in an air medium. And in the second medium, let's see what is the speed. See 0.67 c means less than the first medium. So the speed of light in the second medium is less. That is the reason it bends towards the normal. Okay, now if both the medium are same, let's see, there is no refraction, there is nothing but there is no change in direction. So let's check out the speed in the second medium. Let's find out. One C in the first medium, 1C. Okay. What if I consider the first medium as a glass medium? Okay. Water medium, and the second medium as a air medium. Okay. Now you see speed of light 0.75 C in the second medium, 1 C. See, that is 0.75, here 1 C. Means the speed of light in the second medium is increased. That is the reason it bends away from the normal. Got it? Fine. So this is refraction of light. Let's get back to the theoretical part. Okay. Now, so what is this constant? I said it is the refractive index. What is that refractive index? So refractive index, nothing but it is the comparison of a speed of light, first medium and second medium. Nothing but what is the speed of light in the second medium with respect to first medium. Okay. So that is nothing but a refractive index. It remains a constant for a pair of medium. Okay. It is the remains constant for a pair of medium. So that is the reason it is a constant. How to define this refractive index? And what are the types of a refractive index? So refractive index is nothing but basically it is the sine of angle of incidence to the sine of angle of refraction. So here two types of refractive index are there. The first one, absolute refractive index. The second one, relative refractive index. So what is that? The first one, that is the absolute refractive index. When we compare a second medium, speed of light in a second medium with respect to speed of light in a first medium. Here absolute, if I use term absolute, the first medium should be air medium or vacuum. Second medium can be anything, water, glass, whatever it is. Absolute refractive index nothing but speed of light in the second medium with respect to speed of light in an air medium. That we call it as a absolute refractive index. What about relative refractive index? It is also comparison of a speed of light only of a second medium with respect to first medium. But instead of air medium, we are considering any other two. For example, water to air or air to water. Sorry, not air. Water to glass or glass to water. But we should not use air or vacuum. If we use air or vacuum, then it will be absolute refractive index. Let's see in detail. Okay. Yes. So refractive index, already we know that refractive index is nothing but the ratio of sine of angle of incidence to the sine of angle of refraction for a pair of given media. This is the first one, that is absolute refractive index. The second one, relative refractive index. So here we are considering refractive index is nothing but, okay, absolute refractive index is nothing but speed of, okay, speed of light in air or vacuum. Okay, so divided by speed of light in a medium. In a medium, what does it mean? That is water or glass. Okay, so this is absolute refractive index. We are comparing speed of light in a medium. Maybe it is the speed of light in a water with respect to air or speed of a glass with respect to air. Okay. The second one, relative refractive index. Relative refractive index is nothing but speed of light in one medium. Okay. Medium 1 in medium 1 divided by speed of light in medium 2. In medium 2. Okay, in medium 2. But we should not use the speed of light in an air or vacuum. Anyone, okay, that is only with respect to water, nothing but any transparent medium, but here I am considering optical medium, okay, glass, other than air. Got it? So definition wise, if we see refractive index, the ratio of second medium, okay, the refractive index of a second medium with respect to first medium, defined as ratio of, already I showed you, right? So refractive index is nothing but sine of angle of incidence to the sine of angle of refraction. And there are two types. The first one, absolute refractive index, the ratio of speed of light in air to the speed of light in a medium. So refractive index can be written as, okay, absolute. A means, base A means absolute refractive index. That is given by C divided by V. Okay, so here I'll write V and this is C. Okay, C by U. C by V. Next one, relative refractive index. Okay, so relative refractive index. That is the ratio of a speed of light in a first medium to the speed of light in a second medium. So refractive index, that is the relative refractive index, mu r, that is given by speed of light in a first medium divided by speed of light in a second medium. Got it? Okay, so this is all about a refractive index. Next one, refraction through rectangular glass slab. This is rectangular glass slab. Okay, it is a 3D. Okay, so it is a 3D diagram. But here what I will do is, I'll consider only this part. I'll consider only this part. Okay, because to make it a 2D, this one I consider only this part, that is in terms of a 2D. The same diagram here. Okay, now you see, I'll fill this one with this. Okay, now you concentrate. So first, incident ray. This is incident ray. Okay, this is incident ray. Incident ray. And this is point of incidence. This is a point of incidence. Okay. So just think, what if there is no this glass block? The light would have traveled in the same direction. There is no change in the path of light. But there is a glass block. That is the reason refraction takes place at a point of incidence. Okay. If I name it as a A, B, C, and D, and this is a point of incidence. So from that point of incidence, if I consider normal, okay, if I consider normal, light will bend towards the normal. Okay, light will bend towards the normal. Okay, so this is refracted ray. This is refracted ray. Okay, this is refracted ray, and here for surface of CD, this is the point of incidence. Now for a CD, this one becomes incident ray, and this is the point of incidence. And for that, this is normal. And if there is no medium, okay, if there is no medium, light would have traveled in the same direction. Okay, light would have traveled in the same direction, but there is a change in medium, therefore it will bend away from the normal. It will move like that. Okay, so if we name this one as emergent ray, okay, this is emergent ray. See, this is incident ray, this is refracted ray, and this is emergent ray. This is the direction of incident ray. Fine. And here incident angle, and this is the refracted angle, and here emergent angle. Okay, and here angle of incidence, that is equals to angle of emergent. This is very important point. Okay, they'll ask you to draw the refraction through the glass slab. Okay, refraction through the glass slab, you have to use this method. Fine. Okay, refraction 2 times happened. First one across AB, the second time across a CD. Okay, now let's move on to the refraction in our day-to-day life. Okay, refraction in our day-to-day life. The first one, a coin kept at the bottom of a vessel filled with water appears to be raised. Okay, so this activity you have to do it at home. Okay, next one, a lemon kept in a water glass tumbler appears to be bigger than its size. That is also due to refraction. Second one, the thickness, okay, thick glass slab is placed over some printed letter, the letter appears to be raised. Next one. Pencil kept in a water tumbler appears to be bent when it is viewed from the one side of a glass or from the above. Twinkling of star during the night time. Okay, during the night time, if you see in the sky, so you'll observe like, the stars are twinkling. What is the reason behind it? It is the refraction of light. And actually, the stars do not twinkle. The reason behind it, you will learn in a next chapter, that a human eye and a colorful world. Especially it comes under colorful world. Okay, so in that particular chapter, we are going to see the reason behind all these. Okay, so right now, just you have to know all this phenomena. Reason in the next chapter. Fine. Early sunrise and late sunset. Okay, early sunrise and late sunset, it is also due to refraction. So now, like mirrors. Okay, so like mirrors, here we have a refraction. Okay, for a mirrors, it is the reflection. For a refraction, a lens. Okay, so based on a surface, refraction surface. Okay, if the refraction surface is a flat, we call it as a plane surfaces. Already we have seen in case of a glass slab. What if refraction surface, it is the curved? Then we have a special cases called spherical lenses. Here spherical lenses, here we have a two types. One is concave lens, second one convex lens. Okay, so how this concave and convex lens is made? Let's try to understand. Okay, so first of all, what is the lens? Lens is the transparent material of refractive index, which is bounded by at least one curved surface. Okay, at least one curved surface, then you can call it as a lens. Actually, there are two categories. Okay, convex lens and concave lens. Again, under concave and convex, subcategories 3. Okay, like a concavo convex, plano convex, biconvex. Okay, in the second one, concave, plano concave. Okay, biconcave, concavo convex. So total 6 types of lens are there. But for class 10th, 2 types is enough. That is biconvex and biconcave. Biconcave and biconvex is enough. Okay, now, so if I take 2 spheres, okay, if I join them like this, okay, if I join them like this, you will be able to see this one. So this one we call it as a concave. So this part. Okay, and the center of this one, we call it as the optical center. Okay, the center, we call it as an optical center. If I consider, okay, if I consider these two, okay, it is bounded by 2 curved surface only. Okay, 2 curved surface only. And if I fill this one, let's see, it is a convex. Okay, sorry, ulta. This is, you see, this concave, this one is a concave. Okay, and this one ulta. Okay, so this is convex. Actually, this is convex. Here I'll write convex, and this is concave. Okay, so concave and convex. So this is convex lens, and that is concave lens. Okay, so concave mirror, it is a converging mirror, but here concave lens, it is a diverging lens. Ulta process. Okay, so don't get confused. And this one is, okay, this one is concave, and this one is convex. Okay, so if you see the difference between concave and convex, here you see, it is thick in the middle, convex. Okay, thick in the middle and thin at its periphery. Okay, thick it is a convex. Okay, thick it is a convex, and thin concave. Okay, clear? So I'll bring this one here only. Difference between You see, it is thick like this. Okay, yeah, it is thick in the middle and thin at its periphery, and it converges the incident rays towards the principal axis. Right now, you do not know what is principal axis and all. It's similar to the, like we have studied for mirrors, right? Same way here also. So principal axis, in place of a pole, here we have a optical center. In detail, we are going to discuss about it. No need to worry. Okay. And the next one, it has a real focus. It is thin in the middle. Okay. Thin in the middle. Thin in the middle. Okay. And the next one, it diverges the incident rays away from the principal axis. It has a virtual focus. Okay. So let's see. So here different types of lenses are there, and definition of a lens you can see. It is the transparent medium which is bounded by at least one curved surface. Okay. So let me take out this glass. So converging lens, biconvex, plano-convex, and meniscus convex. And here diverging lens, we call it as a convex lens. Ulta cases for a mirror. Okay, it is completely opposite for a mirror. Okay, in concave mirror it is a converging mirror, but here concave lens it is a diverging mirror. Okay, concave lens it is a diverging mirror. In case of a mirrors, okay, in case of a mirrors, concave it is a converging mirror. Concave lens it is a diverging lens. With respect to convex mirror it is a diverging mirror. Convex lens it is a converging lens. Okay, mirror and lens. Okay, right. These types are not required, just for your information about these types of lenses. Okay, first one, center of curvature. Okay, center of curvature. So do we have no, we don't have. Here only I'll explain. Yes, if we consider this is the lens, the center. Center of curvature. The center of sphere whose part is the lens surface is called the center of curvature of that surface of lens. And radius of curvature similar to the mirrors only, where we use mirror, here a lens. That's all. Same definition. You can go ahead with that. Okay, go ahead with that. And the principal axis same, and optical center. Okay, optical center. See, this is optical center. Okay, this is principal axis and this is the optical center. Okay, so this is optical center and this is principal axis. Okay, this is principal axis. So radius of curvature we consider it as the F1, and center of curvature we consider it as a 2F1. Okay, and this side second focus, that is F2, and this is 2F2. Okay, in case of concave lens, okay, concave lens, again this is the principal axis and this is optical center and this is principal axis. Okay, and in this particular case here we consider as a F2 and this is 2F2, and in this particular case this is F1 and this is 2F1. Okay, clear? So for a convex it has a real focus, and concave it has a virtual focus. Okay, negative sign convention also similar to the mirror case only. Fine, just to replace mirror with lens, same concept but opposite. In place of a concave mirror we have to consider convex lens. In place of a convex mirror we have to consider concave lens. Ulta. Okay, right. The first one, convenient rays are principal rays. What is the first term? I mean first convenient ray. That is, a ray passes through optical center. In case of a mirror, when a ray of light passes through the center of curvature, it retraces its own path. Similarly, in case of a lens, when a ray of light passes through the optical center, okay, it will not deviate. It will move in a same straight line. Okay, same straight line. Optical center. Okay, optical center. So this is incident ray. This is incident ray. And this is refracted ray. But there is no change in the direction of light ray. Okay. There is no change in the direction of light ray. Clear? Next one. In case of a concave, this is incident ray. And this is refracted ray. But there is no change in direction of path of light. This is incident ray and this is refracted ray. Fine. Now, this is a refracted ray, not reflected ray. Fine. Next one, next convenient ray. A ray of light incident parallel to the principal axis passes or appears to pass through the second focus. Okay, parallel to the principal axis. In case of a mirrors, okay, when ray of light, passes parallel to the principal axis, it passes through the focus, right? It is the reflection. But here refraction. Second focus means opposite side. Means out. For example, if I consider this is the lens, this is the first and this is the second surface. This is the first surface and this is the second surface. Okay. Now, see, if a light, okay, incident ray passes parallel to the principal axis. Okay, so this is incident ray. This is incident ray. And it passes through the second focus. Second focus means this one. Okay, this is second focus. This is the first focus. Okay, this side is the first focus. This is the second side focus. Okay, second focus. And this is refracted ray. Okay, this is refracted ray. In the same way, this is actually for a convex lens. It is actually passes to the second focus. But in case of a concave lens, okay, in case of a concave lens, let's consider incident light or ray. Incident ray. As it is a diverging lens, moving like this, okay. But if you retrace the backward, it appears to pass through the second focus. Okay, so this is refracted ray. See, appears to pass through a second focus. Okay, second focus. Is that clear? Next one. I think this is the last convenient ray. A ray either incident from or directed towards the first focus becomes a parallel to the principal axis. Okay. Now, first case, let me consider incident from or direct towards the first focus. Okay. So, first focus. Incident from the first focus. So, this is incident ray. And the refracted ray will be parallel to the principal axis. Okay. This is parallel to the principal axis. Fine. Parallel to the principal axis. This is the refracted ray. Okay. But in this case, appears to pass through the first focus. Okay. Appears to pass through the first focus. What happens? As it is a diverging diverging lens, it will pass through parallel. Okay. Fine. So this is refracted ray. Refracted ray. Got it? So you see, this is incident ray. This is incident ray. Ulta. That's all. Fine. These are the convenient rays or principal rays. And real image and virtual image already we have seen. Okay. So just to go through it. Real image and virtual image. Fine. Now, next one. Special cases, that is the image formation when object is at infinite. Image formation by convex lens. Okay. Object is at infinite position means rays will be parallel. Rays will be parallel. Okay. Rays will be parallel. Okay. Rays will be parallel. Yes. So this is incident ray, IR and IR. And according to convenient rays, refracted rays passes through the first focus. Okay. Passes through the first focus. Okay. So this is where refracted rays meet. This is where refracted rays meet. Same as the reflected rays, okay? If reflected rays actually meets, then it is the real image. Appears to meet, that is the virtual image. In the same way, refracted rays, okay? If two refracted rays are meeting, then it is a real image, okay? So coming back to the characteristics of the image, position of the object at infinite, you can see parallel rays. Position of image at f2. At f2. Second focus. Second of focus. We can write a second of focus. Okay. Next one. Size of the object. Sorry. Size of the image. Point size. It is point size. Okay. Point size. Nature of the image. As the two refracted rays are meeting, then it is a real. Plus inverted. Inverted. Okay. Inverted. Okay. So application of this case, that is burning glass. Okay, so burning glass. So with respect to simulations, let's try to understand. So I'll remove this one. Okay, yes. You see, arrow mark at infinite. Okay, let's consider at infinite. Okay, so let's consider at infinite. The object is at infinite. The object is at infinite on the optical axis. Okay, principal axis or optical axis, same. Now, principal rays. Okay, so principal rays. Principal rays. And here you can see focus. It is not exactly at infinite, right? Parallel rays should consider. Okay, so let's assume that it is the object is at infinite and the image will be formed at a focus, second focus, right? So now second one, let's see. So here you can see image is inverted, means real images, inverted images. Okay, real images are inverted images. Second point, when object, so first I'll finish all the cases, then I'll show you the simulations, okay? Or else it will be tough to handle or increase, decrease the brightness again and again, okay? Right. Beyond 2f1. Beyond 2f1 means, let me consider this position, okay? Beyond 2f1. Okay? Beyond 2f1. This is object. This is object. And how many rays we have to consider? Minimum 2. Minimum 2 rays. So here in this particular case, again, one ray, it is always parallel to the principal axis or optical axis. Second one always passes through the optical center. Okay. Yeah. So this is incident ray. This is incident ray. Okay. So if the ray is the parallel to the principal axis, refracted ray passes through the first focus. Second focus on other side. Okay. This is refracted ray. And one more, if incident ray parallel to the principal axis, this is incident ray, and this is refracted ray. Okay. Okay. And here you can observe two refracted rays meet at this point. Meet at this point and perpendicular drawn to the principal axis. and this is image. Okay, fine. So this is incident ray and these are the refracted rays. Refracted rays, and this is also refracted ray. Okay, and position of the object beyond 2f1. Okay, and the position of the image between f2 and 2f2, and the size of the image you can see smaller. Okay, smaller you cannot write, magnified, sorry, diminished. If small means you have to use the diminished. If it is the bigger, you have to use magnified. Okay, diminished. Nature, as it is inverted, real plus inverted. Okay, and what is the application? Application, that is in camera lens. Fine, camera lens. Now, next case, when object added to f1. When object added to f1. Okay, object added to f1. Okay, now this is object. How many incident rays we have to consider? 2, according to the rule. One, it is always parallel to the principal axis. The next one, it is always passes through the optical center. Okay, now incident ray, and this is also incident ray. Now, if the incident ray parallel to the principal axis, it passes through the focus of a point. Okay, and the second one, this one. So this is where two refracted rays are meeting, actually meeting, refracted rays, and this is also refracted rays. Okay, perpendicular drawn, it is nearby. Okay, okay, fine. So two refracted rays are meeting. That means position of the object at 2f1, position of the image 2f2, and a size similar. Okay, same size, nature real plus inverted, real plus inverted. And the next one, application, that is used in a terrestrial telescope. Okay, the next position of the object after 2f1, between 2f1 and f1. Okay, f1 and 2f1. And two incident rays we have to consider. One, it is always parallel, another one is passes through the optical center. This is incident ray and this is also incident ray. Okay, and this is object refracted ray. According to the convenient rays, if it is a parallel, passes through the f2, passes through the f2. Okay, and the second one, and here they have a common point, that is intersection perpendicular to the principal axis. Okay, perpendicular to the principal axis. This is image. Okay, so this is image, this is image, this is image. Refracted rays, refracted rays. Okay, now, so here characteristics of the images, position of an object f1 and 2f1. Okay, position of the image behind 2f2. Okay, size of the image magnified, magnified. Next one, nature, as it is inverted, real plus inverted. Real plus inverted. Application in a slide projector. Okay, in slide projector. Next one. When object is at F1, F1. Okay. F1. Same rules. Two incident rays, one is parallel always. The second one passes through optical center. Okay. And this is incident ray. And this is incident ray. If parallel to the principal axis, the refracted ray passes through the F2. Okay. Next one, undeviated. Okay. So let's assume that they are converging, right? They are converging. You can see they are converging. So just assume that these two refracted rays meeting at infinite. Okay, meeting at infinite. So meeting at infinite means position of the object at F1, position of the image at infinite. Okay, plus infinite. You can write plus infinite. That is the minus infinite. Here also I have mentioned infinite, right? But it is the negative infinite. That side, negative infinite. Okay. Infinite. As it is the downward position of the object should be also negative, right? Down y-axis. So let me write infinite only. At infinite position, size of the image highly magnified. From here, if you draw perpendicular compared to the size of the object, it is very, very large. That indicates highly magnified. Highly magnified. Okay. Nature, as it is inverted, real plus inverted. Okay. As two refracted rays are meeting at infinite point, so it is definitely the real image. Okay. So application, if you see, that is collimeter of spectrometer. So this collimeter used in a physics laboratory. So when you go to higher studies, we'll get to know what is that collimeter. Okay. For class 10, it is not required, but application you have to know, right? At least. The last position, that is when object is between lens and F1. Lens means optical center. So optical center. So object between optical center and F1. Okay. So this is object. So first incident ray, that is parallel, and another one, yes, this is incident ray and this is also incident ray. Okay. So if it is the parallel to the principal axis, the refracted ray passes through F2. Okay. And this one undeviated. Undeviated. Okay. So here you can observe these two rays. Okay. These two rays are diverging. They are not going to meet even at infinite. Therefore, what I will do, alternate solution, I'll retrace a backward in direction. Okay. Backward in direction. Backward in direction. So here you can see at this point, okay, at this point, the two refracted rays appears to meet. Two refracted rays appears to meet. This is refracted ray and this is also refracted ray. Okay. Fine. So this is image. Now compare object and image. Position of the object between O and F1 and position of image behind F1 behind f1, or else behind the object, or else the same side of the object, that is also fine. And the size of the image, highly magnified, highly magnified, highly magnified. Nature, it is a virtual, because two refracted rays, they do not meet, and a virtual image is always erected. Okay. And application, that is as an magnifying glass. Okay. Next, that is with respect to concave lens. At infinite, infinite means what type of rays we have to consider? Parallel lines. Okay, so parallel lines, fine. And we know that these are parallel lines, means parallel incident rays. As it is diverging lens, what happens is refraction is away. Okay, away, and here also away. Okay, so if I retrace backward, okay, if I retrace backward, so here they are meeting. It is the point size. This is image. Okay, this is refracted rays. This is refracted rays, and here also incident rays. Incident rays. Okay, now position of the object at infinite, negative infinite. Okay, position of image at f2. Okay, and the size of the image, point size, and nature, as two refracted rays do not meet but appears to meet, that means it is a virtual. It is virtual plus erected. Okay, and where do we use this kind of arrangement? In telescope. Okay, in telescope. And when object placed in front of a lens, okay, in front of a lens means anywhere on the optical axis, or else you can call it as a principal axis. Okay, anywhere I have kept object at this particular position. Okay, and this is object. Okay, now incident rays, one, it is always parallel, another one passes through the optical center. Okay, and this is incident ray, and this is also incident ray. And refracted rays, as it is a diverging, this is a refracted ray, it will move the same path. Okay, if I retrace backward, okay, if I retrace backward, this is the point of image. This is the image. Okay, refracted rays. Fine. So characteristics of the image formed by concave lens. Okay, when object is placed in front of lens, front of lens, front of lens. Okay, position of the image between, or else on same side of the object, same side of the object, same side of the object. Next one, size diminished, 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 and nature, as the two refracted rays do not meet but appears to meet, that means it is the virtual plus erected. Okay, application, spy hole. Okay, door, spy hole cameras, or else you can call it as a spy hole doors. Okay, so next one, sign convention. Before that, let's try to understand simulations. Okay, simulations. I'll reduce this brightness. So first at infinite, next one. Okay, you see till f, you see image is there till f. Once I cross this f, you see I'll reduce this diameter. You see same side. Okay, between O and F, first focus and optical center, image will be formed on the same side of the object. Okay, if I consider this one, okay, at any place, if you see any place, the image is virtual. See, on the same side of the object, same side of the object. Okay, clear? Now, sign convention same as a mirrors concept, same as mirror concept only, but in case of a mirrors, we have considered pole of the mirror considered as a origin or else reference point. So from that point, we are measuring object distance as well as image distance. In the same way, in case of a lenses also, we are considering origin as optical center. Okay, in place of a pole, here we are considering optical center. Remaining, everything is same. Okay, so everything is same. Okay, you see, first point. Okay, the optical center of the lens is chosen as the origin of the coordinate system. Second one, the object is considered to be placed on the principal axis to the left of the lens. All the distance are measured along the principal axis from the optical center of the lens. The distance of the object from the lens is denoted by U, and distance of the image from the optical center is denoted by V. And focal length, F. Okay. And the fourth one, the distance measured in the direction of incident ray are taken positive, while distance opposite to the direction of incident ray are taken negative. Okay, same as the mirror case only. Okay, but here a lens formula. Okay, where in case of a mirror formula, here in case of a lens formula. But what is the difference? Only sign. Only difference is sign. 1 by f, that is equals to 1 by v minus 1 by u. Okay, so a few times, students will get confused when to use both mirror formula as well as lens formula. Both are same, but only sign is different. Sometimes students will forget when to take negative sign and when to take positive sign. See, lens, when you remember a lens, last two letters you remember. NS, negative sign. Put negative sign in between the formula. That's all. Okay, this is the trick. Fine. Next one. So magnification, same formula like last we have done. So magnification is nothing but, okay, the ratio of height of the image, HI divided by HO. Okay, and the next one, object distance, image distance to the object distance. So that is nothing but M is equals to V by U. But in this case, we cannot use negative sign. Okay, that is the only difference. Fine. So by combining these two, we can write minus or else HI divided by HO, that is equals to V divided by U. Fine. So this is magnification. Now, question part, NCERT questions. Example 9.3. A concave lens. It is the diverging lens. Okay. Focal length 15 centimeter. Okay. So focal length 15 centimeter. Okay. So concave. So concave means the focal length will be negative. Okay, negative 15 centimeter. At what distance should be object from the lens be placed so that it forms image at a 10 centimeter from the lens? So they have given image distance. So we know that concave lens, it is always forms a virtual image. That means on the same side of the object. Therefore minus 10 centimeter. And here we need to find out u. Object distance we need to calculate. Also find the magnification, that is m value. Okay. So from lens formula, or else lens formula, directly I'll write a lens formula. Okay. Lens formula. Okay. Now 1 by f, that equals to 1 by v minus 1 by u. 1 by f, that is minus 15, that equals to 1 by v, that is minus 10, minus 1 by u. Okay. So I'll, we'll move this 1 by u to the left hand side. It becomes a positive 1 by u. And this becomes a negative, becomes a positive. So 1 divided by 15 minus 1 by 10. Okay. So take LCM. On taking LCM, 1 by u, that equals to, LCM will be 30. Okay, 30. And this becomes 2. And this is 3. That is minus 1 by 30. So u value, that is minus 30 centimeter. Minus indicates on the left hand side of the lens. Okay, right. So next, what they have asked, magnification. So for a magnification, v by u, and v value minus 10 divided by minus 30. Okay, so minus minus get cancelled, and this is 1 by 3. So m is 1 by 3, which is less than 1. Okay, which is less than 1. And nature, if you write, okay, then they have not asked about a nature, but still m is positive means it is a virtual. It is the virtual. Okay. And diminished, because it is less than 1. Diminished. Same concept that we have used in the case of mirrors. Okay. Clear? Find the magnification produced by the lens. Magnification also done. Next question. 9.4. A 2 centimeter tall object HO they have given, that is the 2 centimeter, placed perpendicular to the principal axis of convex converging mirror. Okay, sorry, converging lens of focal length. For a convex, that is the positive 10 centimeter. Okay. The distance of the object from the lens is 15 centimeter. That is, object distance is always negative, minus 15 centimeter. Find the nature, position, size of the image. That means we need to first find out image distance, then magnification, then height of the image. 3 questions. Okay. So first, lens formula. Lens formula. Okay. Lens formula. So 1 by f, that is equals to 1 by v minus 1 by u. Substitute the values. 1 by f, that is 1 by 10. That is equals to 1 by v minus 1 by u value, that is the minus 15. Okay. So minus and minus plus. So that becomes 1 by v. So minus and minus plus, that becomes 1 by 10 minus 1 by 15. Okay. And LCM, if you consider, that is 30. And this is 3 minus 2. That is 1 by 30. Again, v, that is equals to plus 30 centimeter. Plus 30 centimeter. Fine. Next, magnification. So for a magnification, v by u, v is plus 30 and u is minus 15. That is minus 2. Okay. So magnification minus 2. Okay. So magnification minus 2. So here you can observe negative means real image, and it is greater than 1. 2 is greater than 1, therefore it is magnified. It is magnified. So magnified means we have to know what is the height of the image, right? So therefore, again magnification, v by u, that is equals to height of the image divided by height of the object. Rearrange this one. Height of the image, that is equals to V by U into height of the object. Okay. Substitute the values. Height of the image, that is equals to V value, that is 30, U values minus 15, and this height of the object, that is the 2. Okay. So that is nothing but 15 and 2 to 4. Therefore, height of the image, that is minus 4 centimeter. That means below the principal axis. Okay. So below the principal axis. So have we find all the content they have asked? The first one, find the nature. Nature already we got it. That is the real image and magnified. Done. Second one, position. That is plus 30 centimeter. Okay. Size, that is minus 4. Done. Also find its a magnification. That is minus 2. Everything is, we got it. Okay. Now let's move on to the next concept. Power of a lens. Last concept. Okay. So power of a lens is nothing but ability to converge the incident light. Okay. Ability to converge the incident light towards the principal axis. Principal axis, this one. Okay. The ability of a lens to converge or diverge the light rays. Not only converge. If I consider convex lens, it is the power of a conversion. If I consider concave lens, it is the ability to diverge the incident light. Okay. It depends on its a focal length. Okay. It depends on a focal length. What does it mean? So power of a lens is inversely proportional to the focal length. Okay. Fine. Now formula, this one. And unit, diopter. Okay. Diopter. So now if I consider incident rays. Okay. So power to converge. Okay. Incident rays. And these are refracted rays. And here power is positive. So when do we consider power is the positive or negative? If the rays are converged towards the principal axis, then P is a positive. And if rays, that is the refracted rays, diverge away from the principal axis, then you can take it as a negative. Okay, simple. No formula, nothing, just a concept wise. Okay. So these are incident rays. These are incident rays, incident ray, and diverge from the principal axis. Okay. So these are refracted rays. So in this case, power is a negative. Okay, so power, it is the positive for convex lens and the negative for concave lens. Fine. Yes. And the important points that you need to note down. Revise today's lecture. Highlight important concept and questions, and note down your doubts in the notebook, if any. Okay. So when we have a live session, no, that time you can ask. Okay. So here, special instruction, practice ray diagrams. Fine. So that's all for today's session. We will meet you again in a next class with a new chapter. Till then, take care. Bye-bye.